Okay. I'm going to start inviting the panelists for the first session.
Can everybody hear me and see me?
Yeah.
Okay, good.
So we're going to start in like 2 minutes. I'm going to do a short intro. Thank you, Charles, for joining. Antonio, John. We're going to wait for
Daniel, do you have the image to put in the background?
I sent it yesterday.
Can you put the link in the Word document, the shared document, please? Or on Slack or wherever you want. I want to be ready with the right background.
I had that Word document, yeah. Have you changed anything here? I don't see any change.
Hi, Antonio.
Ciao. Can you hear me?
Yes.
Okay.
Okay, so we're waiting for a couple of the panelists. If the panelists join, please raise your hand so that I can find you and upgrade you to a panelist, please. Okay, there is always, I guess, a couple of minute delays.
I'm just wondering why my background is reversed.
We see it well here. Like
well, okay.
Yeah, it reads ZKProof correctly.
I see myself with a reversed background.
Yeah, that happens, but everyone sees it perfectly.
Oh gosh.
Hi, Josh.
Hello.
Okay, I guess we're good. Is Mariana here? Not yet. Riley and Sam. So we're waiting for 3 more panelists, and we'll start in a minute. Just so you know, we're going to be live streaming this session, as well as, of course, anybody who wants can join. So feel free to share the link that you used. And we're going to record the sessions. So that will be also something good.
Do we also get to see the the people that logged in, or is it only the speakers?
Yeah, sorry about that. That's the feature of the webinar in Zoom. Only the speakers get to see and speak, so show their faces at least. Yeah.
So guys, we all need to accentuate our reactions to each other so that we can get some feedback loop.
I work from the background.
Hi, Sam.
Hi. My computer does not accept virtual backgrounds, it turns out.
It happens to me as well. So, okay. So we were waiting for Mariana and for Riley. I guess they should be joining in a second. Okay. Hi, Riley. How are you?
Hi, I'm good, thanks. It's quite late in Beijing, but great, in Shanghai, but great to see you guys.
Yeah, thank
Great
you for
to see
joining.
you. Thanks for joining us.
So, okay.
All right.
Mariana is not here yet. I'm going to start so that we don't get too much behind. And as I make the intros, I'll check if Mariana joined, so we can add her as well. Okay, so thank you everyone for being here. We're very, very excited for this last day of the ZKProof workshop home edition. It has been quite a ride. Many of you have gone all along with us, and we're excited for this final session. So today is going to be a little bit different. We explicitly wanted to make it so that it would be more accessible and sort of create a feeling of closing a loop and coming together on what's the vision of the field. We have prepared 2 panel discussions, very interesting, and 2 short talks for your eyes. And we have a closing ceremony with surprises and prizes. So we really encourage everyone to stay. It's going to be really fun. You know, we have some really cool stuff waiting for you. And okay, Mariana's right here. And so without further ado, the first panel discussion is going to be on industry adoption and deployment with Josh, Mariana, Jonathan, Riley, Charles, Antonio, and Samantha is going to be the moderator. So I will start recording, and Sam, it's all yours.
Wonderful. Thank you all for joining us today and for being part of this workshop. This discussion about industry adoption and deployment brings together people from all different backgrounds across the industry with different views on where privacy needs to be centered and where trade-offs should be made. So thank you all for joining us. My name is Samantha Stein, and I'm the CSO of Kedit. I'm also a media leader with the World Economic Forum. So I'd love to start just by having everyone introduce themselves and share a little bit about what brings them to this workshop today to give us more context. Antonio, why don't you start?
Yeah, hi everyone. I'm Antonio Senatore. I'm the global CTO of Deloitte in the blockchain space. I'm based in Dublin, Ireland. So happy to be here, guys. Hello, everyone.
Thank you for joining us.
Hi, I'm Charles Hoskinson, Chief Executive Officer of Input Output. We're a research and development firm in the blockchain space, and we do a lot of research in the privacy space and with zero knowledge proofs in particular.
Thank you for joining us.
Hi, everyone. I'm Josh Cincinnati. I'm the Executive Director of the Zcash Foundation, which is focused on researching and building privacy in financial infrastructure online with a particular focus on Zcash. Yeah, I'm very excited to be here as well.
I can go next. I'm Jonathan Roush, CEO and co-founder of Kedit, and very happy to be a sponsor of this event for this event and past events, and happy to be in this panel.
Hi, my name is Mariana Gomez de la Villa. I'm the Global Program Director for DLT within ING, and I'm really happy to be invited. Thank you very much for the opportunity.
Hi, everybody online and everyone that's watching. My name is Riley, and I'm joining from Shanghai. I work for Ant Financial on the international investment team. So great to talk to you guys all virtually.
Wonderful. Thank you so much for joining us across all of your different time zones. So one of the things that is most critical for anything succeeding in this industry is sales. We have to be able to make a saleable product. So I'd love to start out by talking about what everyone thinks the bottlenecks are to realize for sales with the zero knowledge proof based product. Is it technical? Is it the market, standards, usability, all of it?
Well, we tend to have a holistic and industry-wide view, and we look at problems we want to solve rather than particular pieces of technology. I mean, selling a ZKProof or something in this industry would be like saying, well, how do we sell this processor bus, or how do we sell this very particular component of a GPU? You have to say, well, that's part of a larger thing, and that larger thing has to, as a whole unit, provide value. For example, we look a lot into e-voting, and we look a lot into supply chain, especially in Africa, and we deal with projects sometimes that have 6 million farmers. And so they're saying, well, how do we prove facts about these farmers? How do we prove facts about the supply chain or things that are entering while preserving privacy or enforcing self-sovereign identity? So we view zero-knowledge proofs as very much an essential component to building a productive system that preserves privacy and has a nice balance and trade-offs. But we don't try to sell a system directly and say, well, come here and buy our zero-knowledge proof system. There are some companies in the space that are selling these things, like Starkware, for example, and then that's simply a very boutique thing where there's a collection of customers that really need that, like, for example, Ethereum for scalability or other such things. But we tend to look at it as an intermediate component of a larger chain, and all those things together are what we sell as a package.
Thank you.
Maybe I can add the on the enterprise angle. The big challenge is, like you said, you're not selling. You're even further than in cryptography in selling a stack of technology. You're going all the way to figure out what is the end application, who's the end payer for the application, and then. Do these clients realize even that they have a privacy problem? It's not very clear. Often you have, for example, in supply chain, the first order problem is just figuring out what can I gain from moving my infrastructure to these new technologies, and they then once they move, they realize, oh, but everybody else can see my data. So just having even the understanding of the problem is a challenge.
Yeah, I mean, I'm with John and Charles there. Absolutely, selling what the vision is, which is what is the use case, the problem you're trying to solve, and sometimes there's no clarity about that. I think it's also a problem of education in some extent. I mean, we are all accustomed with, the world of enterprise software. And not only, also users, up to an extent, are accustomed to privacy or to modern cryptography in some extent. I mean, you got SSL, you got TSL, you got PKI in organization, you got HSM. There is an understanding at CIO, CTO level what you're trying to do there. It's not there yet in the ZKP space. That's why we are doing this.
There's a category. What's our category?
Yes, yeah, but that's why these conferences are important. By the way, that's why we're here. I suppose education. So education is the first one, in my view. So and then being able to explain to the C-suite, and of course, getting that education level out there. For my work as a CTO, as the guy that implements solutions for multiple clients in multiple industries, you mentioned supply chain, can be anything. Financial services, etc. The tooling becomes a large part of it. Things get successful when developers can do things fast and quickly. Even bad ones, even bad developers, average, don't need to know much. So that's another one, a bottleneck for adoption, because it's quite complicated now to really set up proofs unless you got specific APIs around it. So that's just a couple of points to start the discussion.
Yeah, and sort of that. Oh, sorry, someone else.
Okay, I just wanted to add as well to what Antonio just said, the fact that sometimes, for example, in the enterprise world, you are working with a group of people, right? And that group of people has to define a governance. And sometimes, that group of companies working together to achieve, a specific implementation on a use case, have to also have indeed the same understanding and have to understand as well that they may have the right to play in order to tackle privacy in their specific use case, right? And sometimes I think that understanding is missing. You know, sometimes I think that the privacy and confidentiality of the use case needs to also be provided by the enterprise firm that is providing actually the platform or the fabric upon the one that you are building your case. So having, as Antonio mentioned, you know, the understanding on where exactly do you need it, like Jonathan said, you know, if it's on a trade, for example, whether you want to know who is your primary source of that specific commodity, where is it coming from, you know, what aspects you're allowed to see along the change and what aspects you shouldn't see along the change. That's something that matters to everybody, and it should not be solved only by the technology provider. It should be solved by everybody according or depending on the use case that you are trying to implement, right? So yeah, that's something that you need to take in consideration, and it may vary per use case.
Yeah, and I was just going to add in the Zcash use case, like we're kind of lucky in that we have a very specific focus for what we want to build, which is effectively digital private cash, and that's it's really clear like what's driving us. But we actually face a lot of those sort of similar, I think, education and advocacy challenges that you might see on the enterprise side, because one, the broader public, you know, to some degree doesn't really understand why that's important right now. I think that frankly, as a result of all the various data breaches and sort of government overreach that has been happening a lot in various corners of the world, that story is getting easier to persuade and sell people on. But what's actually still becoming harder, even when you can sell people on that story, is like, you know, in Zcash's case, Zcash was one of the first protocols to deploy this, you know, a zero knowledge system at scale in production. But it was still extraordinarily difficult when it first came out for people to actually leverage those privacy features. And oftentimes when people were interacting with the, you know, Zcash legacy sort of Bitcoin equivalent addresses and transactions, a lot of folks, I think, assumed that they were operating with the same level of privacy without realizing that they needed to actually be using shielded addresses and you know, transactions to shielded addresses. And it was very difficult.
There's something similar. Sorry, just in private blockchains, people hear private blockchains and they think, oh, they're private blockchains, so they're private blockchains. It's the same kind of
yeah, it's a real no, that's right. I think that people just sort of make that assumption, but then there's this whole other level of detailed education that's necessary in order to demonstrate like how to use these things. And you know, I think something that Zcash has struggled with is like the initial deployment really took, you could only access shielded transactions through a Linux command line tool, basically. And so the usage wasn't very high. And I think that it's sort of this combination of us making that more usable, which, you know, huge credit to the Electric Coin Company, because they were the main drivers behind deploying Sapling, which is what enabled all of these now more lightweight options for engaging in shielded transactions and proofs. But we're only now starting to get light wallets and hardware wallet support and all these other things that are necessary to actually bring usability onto the same level as more transparent Zcash or Bitcoin transactions.
Yeah, Sapling is a great product. We spent over a year working with it when we were implementing Sonics, and we reused about half of the code for it. And so I just want to follow on and say that it's great to see this kind of rapid innovation. And it's, you know, you have to get to a certain level of usability and maturity in a technology stack before you gain commercial confidence in that technology. The internet is a great example of that, and web browsers were another example of that. And also you need to get a certain level of industry standards that mature. Could you imagine using the internet if we had 45 different programming languages besides JavaScript, and none of them were interoperable and you had to pick and choose what to deploy on? I mean, I remember the 90s when you actually had to deploy broken cascading style sheets because Internet Explorer 6 didn't actually follow the standard properly. So that's another domain that is a bottleneck to sales, is there's a maturity and a standardization component, which we aren't quite at as an industry yet. but these types of conferences are tremendously helpful for that. And the amount of work we've seen, especially over the last 2 years in particular, not only of today's technology, but tomorrow's technology like recursive snarks, is really remarkable. So the time for commercialization isn't quite there yet, but it will be here soon, and it'll be driven by standards and quality and maturity.
Charles, you bring up a great point about standardization and how this can help relieve some of the complexities the space is facing, and especially looking at how that's historically happened from other industries. I'd love to hear from the other panelists, what are the ways and you think standards can be helpful in the near term and long term in terms of helping to advance industry adoption?
I can, if I can add to what Charles said, it's not by accident that the three first people to mention Sapling are the main sponsors of this this workshop. This is the most the protocol that got the most production use in the real world of cryptocurrency, and then in enterprise. We decided to standardize this because this is needed. We're not at a standard yet. I don't want to disappoint everyone, and there's clearly a lot of really good work here, but we don't have a standard yet because things are still moving, even in those in those protocols that are seeing use. But the place that we play this standardization card, this is what we can reference to when we go talk to people that shouldn't understand anything about zero knowledge at all. This is when you say NIST is helping us draw this, write this document, that's all you need to know. And maybe Riley, the NIST is a big name in China as well. I'm presuming all the SHA-256 and all those standards are used worldwide. It's a place where you can point, this is how it's done. And it's done in the open.
So I think just to like add on from a perspective, right? Ultimately, I think with any of the scaling for technology, the core of it is really, do we have a business issue and an incentive from the business end to drive this specific technology compared to other technologies? And I think especially for people who are working outside of just ZKP, if I'm impartial to the actual technology itself, it's really about the application of how useful that is to my current business industry and my current business logic. So I find that, I think, for Ant and what we're doing also within China, in many cases, ZKP isn't the only way to solve the privacy issue, right? So there's like lots of other types, MPCT, etc., and obviously with pros and cons on different verticals. And I think there is up to the brain power and the education and also the popularization of, specifically for ZKP, how that's different and how that understanding should be the way that we can adopt to go. Because I think now we're at a too early a stage to say, okay, this is definitely the place. I guess going back to that browser example, that's such an interesting example that I didn't know there was like 50 different browsers people could choose from. Now it almost seems like by default. So I think it's still evolving, and for me, I think a lot of it is driven by how big and how critical is that business topic, and can we scale that fast enough to use ZKP to adopt that so it is ahead of the others.
If I remember correctly, there's the competing technology here is trusted execution environment, right? It's even in Corda, the first steps that were taken were let's slap Intel SGX onto the problem, and privacy is not a problem anymore. It goes away because this hardware will solve it for you. This is a bait.
Yeah, and
that's the bait, right?
That's a tremendously tempting competitor because it's in billions of devices, and there's ARM Trust Zone, and there are many people who are deploying trusted hardware modules and using them somewhere in their product chain. But then you're completely surrendering the trust of the model to the hardware vendor, and then it almost feels like the Clipper chip all over again in that respect.
Yeah, I agree with Charles wholeheartedly on that, because effectively it's almost like you're carving out you're saying you're carving out risk in the system by just relying on this one, piece of hardware and saying, oh, don't worry about it. We've totally removed all sort of privacy leakages because we're just using this trusted execution environment. But that effectively is like a centralization risk and a trust chain risk. So I definitely have a preference for other, not that I'm I'm like a half developer at best, but I definitely have a preference for approaching models very, very differently from that approach that people generally take.
Yeah, and trusted execution does give you a lot of really cool things that are super hard to emulate in software. So if you move beyond privacy, you get proofs of secure erasure, so you can guarantee that things were destroyed or only seen once. You could also enable offline, off-chain transactions with that. So if you want to actually to create a real-life form of a digital asset, you can do that with a trusted environment. But I'm a bit skeptical of it being useful in the zero-knowledge space or enabling privacy. I think it's quite the opposite. It's a Trojan horse that seems like it's private, but actually will have a backdoor in it somewhere, somehow, some way.
Yeah, I'm with Charles. I don't see how trusted execution environments. I know that they are proposed as a privacy solution as well. I don't see. I see them as complementary. Definitely doing other stuff that is cool and necessary, and we can get there very quickly. And zero-knowledge proof providing privacy layer and the features that we know. So it's definitely, I don't see them, although they're probably sold as competing solutions to similar problem. I don't see that, but that's my opinion.
Yes, I tend to agree with Antonio as well. I see them, that it can complement each other. And when you really study what exactly is the privacy that you need and why do you need it, in which parts of your value chain actually that is needed, and pretty much looking at the problem that you're trying to solve is when you really have to choose either one or the other, or maybe both, or maybe none. Maybe there are other quicker ways to actually do that. It is true that, for example, the evolution of zero-knowledge proofs it is quite nascent, right? It's not something that has a lot of time, or it hasn't been battle tested the way, for example, trusted execution environments have been, and probably that will also bring a set of education that we have to do as well to governmental institutions. If you want something to be actually approved, and at least us as financial institutions, we need to get any change on the market infrastructure approved by our regulators. Then they also need to understand this type of technology. They also need to understand the limitations. For example, they need to understand what kind of constraints you might hit, and how are you going to actually manage those risks, right? Whereas, for example, in a trusted execution environment, you might be able to have liabilities pushed towards a vendor. And in this case, if you're the one implementing this specific cryptography primitive, you need to make 100% sure that everybody understands what it means and what kind of measurements or risk management are you putting around it, right? So I don't think it is either or, and you really have to look into why are you doing this, rather than who is the one that is selling it to you, or who is the one that is solving this problem for you.
Yeah, it's also important to understand what we're trying to accomplish with a lot of zero-knowledge cryptography. So there's many things in business processes which are threshold questions. So a great example that everybody can relate to is, if you want to buy alcohol in the United States, you have to be over 21. So how do you prove that? Well, you pull out a driver's license or a passport or some identity document. What are you actually trying to prove? You're trying to prove that you are at or over a threshold. But in the process of proving, because the tool to prove is not very precise, you're leaking your name, your address, and whatever else is on that identity document. So the point of zero-knowledge proofs gives you a much more precise instrument to prove thresholds. Did you pay your taxes or not? Is this a customer you're allowed to do business with or not? Is this customer an American or not? But you don't have to reveal anything else above and beyond that particular threshold. It's a super powerful, precise thing. And then that makes it much easier, getting back to the sales question, to sell to businesses, because in the process of dealing with imprecision, you take on business risk. For example, if you're an exchange, you have KYC AML requirements, and then you inadvertently become a data warehouse. and then all of a sudden end up with all this customer data that you can't do much with other than have to hold for 7 years. And it becomes a liability because if you get hacked and it gets leaked, then it's a business problem for you, potentially a litigation problem or a regulatory problem. Whereas if you have threshold systems, you collect the minimum of what you require and need and nothing else. And so you're actually preserving privacy, but you're improving efficiency and you're improving the customer experience. So that's something that kind of differentiates the trusted execution environment from the zero knowledge environment, because you're thinking about things just a little bit differently. You're saying one is really good for threshold type things. Are you in this set? Are you not? Are you this person? Are you not? And the other is kind of designed for a different class of things. It's a special enclave to do a litany of operations that are isolated from the normal operating system. And there's a lot of great business cases built around that, like Samsung Knox and so forth. But you shouldn't look at that as a privacy panacea. It's really not. The zero knowledge side is much more amenable to that.
So thank you so much for that answer. And I'd love to answer some of our questions from the audience and flow with the conversation. So the first one is from Markov. Is it possible to combine trusted hardware and cryptography to get the best of both worlds?
Yeah, there's
yes.
There's definitely a place for that, but if you do it sequential, you get heard from the weakest link, right? So if you're adding a security or adding a reliance on a new system, but that new system, if it's hacked, you lose all of your security assurances, then you haven't done anything. There's places, for example, where what's at stake is less important in some cases. Let's say you transfer cash and you want to reach really high scale for small amounts, but for big amounts, you're willing to to incur the cost of the amount of time it takes to prove, and you want to upgrade to a more open cryptography approach. So you could have a mix of both. I think there are places where it's being trialed.
Yeah, and one really good practical example is that a lot of these zero knowledge systems require what's called a trusted setup. And so if you merge trusted hardware with the trusted setup component, you can add an additional layer of security. So you say, okay, well, we need proof that these keys have been destroyed. And so you could use trusted hardware to provide a proof of that. So you kind of have two layers. You can do what you do with existing federation and social processes, then you add a trusted hardware layer on top of it to show that key erasure has occurred. And you can probably find a lot of complementarity with a litany of these protocols where you're adding some value there. But I tend to agree that it's counterproductive to think that trusted hardware actually somehow improves trust, privacy, or other things, because there's a backdoor into these systems, the central vendor who created it. So you're basically saying everything is secure and decentralized as long as Intel plays, or everything is secure and decentralized as long as AMD hasn't done something, and that's not the point of at least a lot of software.
About that, I'm not too opposed, as obviously from talking from position. Having trust in a vendor is something that we do all the time. The problem is that what is your mechanism to see, to verify if there was a breach? If it's a black box approach, then it's very difficult for you to even know what happened. Right. And then you would like to trust vendors, but it's just impossible technically to do so. But we trust vendors pretty often, right?
Right. Well, you got to remember, I always come from the perspective of decentralize as much as possible. So whenever I see a centralized backdoor in my system, I say that's no good. But you're generally right for enterprise sales or a traditional business. It's perfectly fine to trust Intel. It's probably more reasonable to trust them than any blockchain company.
And can you also discuss the difference between a TEE and a trusted setup?
That's a Zero Cash Foundation question if I've ever heard one.
Yeah. Sure.
Roush, you ready for it?
Well, I can at least talk about the trusted setup piece, although I'm less knowledgeable on the trusted execution environment. But yeah, so a trusted setup is a necessary piece of any system that's that's using something like ZK snarks. You effectively have to engage in for lack of a better term, this ceremony where you generate a bunch of keys that you, in order to enable use of this use of this zero knowledge system in a succinct way, you have to throw out all of these keys that you generate. And so typically what winds up happening is that you get like the first Zcash ceremony was only 6 participants, but then the second one with Sapling was I think 180 in aggregate. There's a sort of a first stage, Powers of Tau, and then second stage that was specific to the circuit design of Sapling. But the idea behind a trusted setup is that so anyone who, at least in Zcash, the way it works in Zcash is if you somehow manage to recover all 186 keys that were generated, all the data, well, not really keys, but data that was generated in that ceremony. If you were able to recover all of that, you would have visibility into the sort of private pool, and you would be able to like effectively manufacture certain proofs that would destroy the privacy of the system. But the thing is, it's very, very unlikely, given the diversity of both participants and their own setups, that you would be able to recover all of them. I mean, you'd have to. It's super unlikely. That said, I think people still are worried about the nature of those kinds of systems, which is why there's been so much research into either creating zero knowledge systems that where one can continuously add on participants, as is the case with Sonic, or where you can do trustless, effectively no trusted setup required, which is some of the breakthrough research that's happening at the Electric Coin Company and other places. So I mean, I think that there's a recognition that that is a potential like backdoor into the system, although it's like incredibly unlikely in like the Sapling case, for example, that someone could recreate all of those and recover all of that data to actually cause some harm on the privacy side.
Yeah, it's one of those, you get something for something. There's nothing for free in life or mathematics. And a trusted setup says that there's very particular mathematical primitives that you're working with. And as long as that scaffolding is kept secret in its aggregate, then basically you get something from that scaffolding. So the more people who build it, the more diverse they are, and the more clever you are in making sure that their individual components are obfuscated or destroyed and get proof of that, then the more secure that scaffolding happens to be. There are things like class groups and other things you can use. And I think there's a great paper out of Stanford, what was it, Dark, where there's a lot of investigation to systems that do not require this trusted setup, or you can add more scaffolding over time. And this is just going back to that maturity component. How do you mature the ecosystem? Well, this is the fundamental research that's required to get us to the next level. And eventually you cross some sort of threshold where you say, yeah, we're not so worried about it anymore. The scaffolding's strong enough, and we're reasonably confident there's no problem with it. I mean, technically you can reverse a Bitcoin transaction. It's theoretically possible if you have enough mining power, and somebody could be secretly mining, with the world's largest ASIC pool and create a different chain. But obviously unlikely because the system is so mature and so strong. And so this is that same situation in analogy. Now, your other question was, what's the difference between that and a trusted execution environment? This is special hardware that a vendor has to create, whether Intel or Qualcomm or somebody who makes chips for a living. And that special hardware has its own memory, its own computing power, and its own way of handling data. And because it's shielded and separate from the normal computer, you can use it as a safe place to store private information, safe place to store programs, and you have a reasonable level of belief that one can't influence the other. So even if the primary computer, your cell phone, your desktop gets infected with a virus or malware or keylogger, the trusted execution environment will be able to operate without that enclave being breached. Also, code that runs in that enclave generally has to be signed by the vendor. So Intel has to sign it for it to run in the TE or something like that. So it means that you have much more limited set of programs that can operate inside that environment than what operates in the main environment. So you tend to use that for situations where you need to hybridize devices, like the whole bring your own device for work. Like my employees use Slack. A lot of them connect through Slack through Samsung Knox on their phones. So Slack lives in a trusted hardware enclave, and all the work information files are there, and they're managed by that policy. And then I, as an employer, have a lot more control over the secure erasure and handling of that information that's inside that domain than if it was just sitting on their iPhone or their Samsung device naked, as a consequence of the way we manage things. So there's certainly different things. One is software and theoretical, the other is physical hardware, but they do have some overlaps in terms of capabilities.
There's one thing. Oh, go ahead,
I was saying, John, you can imagine for trusted execution environments, then the applications, especially in governments, financial services, that ability of having information stored in a trusted environment, and also software that runs only from a specific vendor, and software that is signed. There's a lot of applications there. Imagine private information on citizens, for governments, same in financial institutions. Charles just mentioned Slack, but it's there's a lot of need to keep in the enterprise space and government space to keep information secured and stored and not accessible, and that is executed. Any execution that runs against this information is kind of protected and shielded. So that's it's a piece of technology that is extremely useful. So that's extremely.
There's two comments on that. The first is, the governments are looking at getting more and more calculation, more and more secure, and there's actually programs now that are pushed to see if zero knowledge can match what happens in trusted execution and have a huge scale of calculation in zero knowledge proof. That's very advanced research from DARPA to try to push.
You also need homomorphic encryption for that. It's not just zero knowledge. You need homomorphic encryption for that, not just zero knowledge.
It's privacy enhancing techniques in general, but in this particular case, they put a lot of effort in the zero knowledge proof space. But just to go back to the TE versus trusted setup, in both cases we see that very quickly we go into details, technical and technological details, where most people lose touch with what goes there and are looking for, okay, so who do I need to trust that they verified that the trusted setup happened correctly, or that the chip is running correctly? Like, where do I get my V? What's the process for me to know that things are fine, right? And in trusted setup, we actually had a bug, right? We had all the protocols great, but there was a typo in one of the white papers. So we knew that the community will be looking at those papers and those problems at with the highest level of quality. And this is exactly how we pour trust into those systems. If it's a closed type of system, then we need to wait for the next release of the chip. And if it's an open system, like a protocol, a cryptographic protocol, then basically people are counting on us, right? That this type of workshop and these type of gatherings to make sure that we have their back, right? That the community is watching every little detail of the technology.
I'd like to combine two questions into one, which is, what traditional businesses have to switch? What incentives do traditional businesses have to switch to zero knowledge, which could mean large infrastructure changes? And then what projects or collaborations are necessary to help the ecosystem get there?
Well, liability reduction, I think, is probably strongest and most immediate. If I can avoid it, don't want to collect large amounts of information about my customers, especially personally identifiable information, because especially if I'm, from a regulatory perspective, not allowed to monetize it, all it is just a negative asset on my balance sheet. It's something that I have to spend money to secure, protect, and do something with. And then anytime I have an employee breach or a hacker or something like that, I'm just creating problems for myself. So if I can go to a business, whether it be a bank or an exchange or a healthcare vendor, and say, look, you don't actually have to know much about your customer. You can use these systems to prove what you need to do business with them. But outside of that, you don't have to store any information. It simplifies their business enormously and saves them a huge amount of money.
For us at ING, for example, it has been the fact that we are heavily regulated. And back in the day when we started experimenting with blockchain, it was more or less 2017. And when we started experimenting, I mean, like going into production with some pilots. And we realized, obviously, that even though you had private networks, you would still have certain privacy and confidentiality issues. So we started experimenting as well with zero knowledge proofs. That's when we launched our first open source protocol. And from there, we kept researching on the technology because we saw it was quite suitable for a lot of different use cases that we had. If we wanted to move different asset classes from A to B, for example, or to trunk the provenance of a specific assets, the price, etc. Right? There are cases where you want a specific parties to be able to watch or to see the whole line, let's say, or the whole blockchain. But there are other times where you really don't want that. So you have to be really careful on how you actually implement each one of the asset classes and how you tokenize it. And where can you actually use zero knowledge proofs to prevent indeed those parts being seen, by other parties that you may not want to. Throughout the years that we have been experimenting with this technology, we have open sourced actually 3 different primitives. And we are still betting on this type of technology because you don't have to, as everybody has been mentioning, you don't have to actually trust hardware or a technology provider in order to be able to achieve the privacy or confidentiality that you may use or need. So that's one of the main drivers, and it's really interesting. I think that the ecosystem is really growing, it's really evolving. The collaboration that you have going on, it has really come from thought leaders, people that you would have at school when you were studying, for example, cryptography, and that's something really cool that those are still alive, and you can actually ask them questions and you can actually work with them. So that's also probably like one of the greatest motivations that we have, right, to work on that.
Yeah, actually, what's so cool is Silvio Macaulay is kind of the father of the zero knowledge proof, and he's recently entered the blockchain industry with a project called Algorand. So what's old is new again, and you definitely can talk to the pioneers still. I studied math, and all the people I studied are dead. so it's nice to be able to talk to the people that are still around.
Yeah, one thing about Mariana, what you said on seeing all the data in the blocks and then moving to those techniques that hide that. There's a demonstrator of exactly this. How do you see zero knowledge proof in blockchain, like in practice? It's a sort of shameless plug, but I think it's interesting. It's called the hands-on lab. It's something that VMware developed. It lets you see what a blockchain looks like when you can see everything, and then you add the zero knowledge proof layer, and you can see, oh, okay, so this is what's happening. This proof is being generated to show that ownership has changed, and this proof is generated with to show that the asset actually existed in the past. Kind of explains before and after privacy in a very visual thing. So if people are interested, I can put the link. Like, it's called Hands-on Lab. It's like an hour of online virtual course that you.
Please do, Jonathan, because we were actually, summoned by Ralph Hammers quite 2 years ago, more or less, to explain what we were doing on zero knowledge proofs when we had the first breakthrough. And I remember it was so hard to try to figure out how are we going to explain to the board of ING, what zero knowledge proofs are. Nowadays, if you actually talk to them, they would totally understand, and they would tell you different use cases because they are obviously quite clever people. But I remember, in the beginning, we were like, oh my God, how are you going to crack this nut? And how are you going to make sure, that they understand how important it is actually for what we're doing? And for example, one of the successes is that, during this COVID, there was a call for action, right, by our government in Holland. And people, within ING, senior managers would knock on the doors of the DLT team asking, okay, guys, what you have done on zero knowledge proofs could help, prevent that someone actually walking on the streets that has the COVID, might contage someone else, and by zero knowledge proof implementing it, you could actually keep that person anonymous, but still know that you are around, the proximity of someone like that. So it is amazing the way they understood it, for them to be able to even tell us, what kind of use case they saw for zero knowledge proofs, which I think is a great achievement.
The fun part is that they start saying zero knowledge proof in cases where what they mean is privacy techniques, like advanced privacy cryptography. They don't really know, MPC, Bloom filters that are like the hash compare. They don't really care. They call it with the first thing that they heard. So if they heard homomorphic encryption first, then everything is homomorphic encryption. And if they heard zero knowledge, it's zero knowledge.
Or maybe it's like Kleenex, like once a brand reigns, like people start using that instead of the term for it itself, tissue paper. So maybe give some more credit to the space, John.
I did hear zero knowledge proof as a solution for COVID tracing. I also heard the same for private set intersection, and also the same for hash and compare, and also the same for, like, there's many different ways to solve this problem, and everyone got introduced to it from a different angle.
It reminds me when Microsoft paid a bunch of money to sponsor the NFL, and they gave all the teams Microsoft Surfaces, and the football announcers during one of the games called the Surfaces an iPad. So it shows you that once the vocabulary is set, it's very sticky.
Yeah. So we have about 10 minutes left, and we have a lot of questions from the audience. So I'll do my best to answer them all with the panelists, and for the ones we haven't answered, I hope you all can find some time to get them answered later. So our next question is, what should be standardized first in zero knowledge proofs for a company to persuade customers? Is it a specific scheme, such as a proving scheme, or is it a specific curve or more general protocol?
That's jumping straight into what people are discussing in those closed rooms here in the workshop.
Mm-hmm.
I think there was an interesting work on trying to make interoperability be a thing in zero knowledge, so that the work that everyone is doing can be reused in other people's work. So the first place that we started, I don't know if it's standardized, but at least talk a common language, is this area of how to represent proofs. And make sure that if you have a library that speaks one language, it's still usable in another zero knowledge library. So that's kind of the first standardization approach. The second one is I think figure out across all of the different offering, and things are moving super fast, what's already being used, and say and put that as a candidate for standards, because that already has a lot of lessons built into the to the libraries and the underlying schemes. So just detect what passes the bar to become one day a standard, and focus on that. Of course, this workshop has become more than just standardization, because people use the occasion to showcase the latest and greatest, and it's going to take a few years until that becomes calmed down and in products, etc. But we have all this going on.
Standards are difficult because there's what you want to achieve, and then there's what the market tells you to do. There's more than one person floating around that would like to get rid of Bluetooth or Wi-Fi as it is, replace it with their favorite thing. Even in our own company, we're RINA fans, recursive internetwork architecture. We say, get rid of TCP/IP, throw that whole thing away. That's stupid. Let's do something differently. But of course, the market strongly disagrees, so we stay where we're at. So I think what's probably going to end up happening in practice as this field matures is we're going to see a collection of breakthrough products that really get strong adoption. And then the standards will be sculpted around those breakthrough products, whether these products are superior in terms of technology or perhaps even secure. So that's the first thing you have to understand, that there's a universal law of business gravity, and whether you want to do the ideal thing or not, it's going to pull you in a particular direction. The second thing is capabilities. and trade-offs. And we're not quite as an industry at the point where capabilities and trade-offs are optimal, and we're very happy with everything. The systems are still a bit too slow. They still have some inconvenient setup requirements. But what's interesting is the volume of research is accelerating dramatically, and the quality of protocols is really improving dramatically. In fact, the last 2 years in particular, we've seen this. And I think over the next 2 to 4 years, we're going to see an enormous amount of effort coming. So I think those trade-offs will fade a bit. So if I had to guess when really serious standardization efforts are going to occur, I'd say probably in 2023, 2024. It's impossible to know what that's going to mean, whether it's going to be trying to fit an industry winner to be more reasonable, or like what we had to do with JavaScript. Terrible language design, but we have to all live with it. And we spent 20 years as an industry slowly cleaning it up. Or it be that we actually can do something right from the beginning. We'll find out, but standards are always difficult in that respect.
There was one thing that was very useful about attempting to do a standard, and all the work that went into the documents, is that became a reference for that big project that I mentioned earlier, the DARPA SIEVE project. So now there's teams that needed some form of intermediary representation of their circuits, and they looked around and said, what makes sense to look at, and to what would be our format to communicate between the teams. And it's such a large project that you have to have a format to communicate between everyone. Otherwise, you're not going to be reusing the work of the different teams and combining them in a stronger way. So we basically, this community has produced in the past 3 years, this milestone that maybe we didn't do a lot of noise about it, but it is useful. And now large, it's tens of millions of dollars in that project are basing their efforts on partially on what happened here.
Wonderful. So I'm going to take one more question from the audience. And this last question is, there seems to be a large movement towards open source software. And thank you to everyone who's involved in the open source movement. Will enterprise companies look to contribute to open source software and integrate it into their stack, or will they look to create in-house solutions, and why?
I mean, in general, all industries are starting to move towards open source. The bellwether moment was when Microsoft open source.net. I mean, this is the company that the former CEO used to call open source software cancer. And now they're one of the largest contributors to open source software in the space. And we see it in the blockchain industry with Hyperledger Foundation, Linux Foundation. And everything we do is open source and patent free. And that seems to be the rule as opposed to the exception to the rule. There's very few successful ventures in our space, if any, that actually pursue intellectual property and patents.
In our case at ING, we also do open source, for example. We have 3 projects that we have open sourced to the community. And we also do some stuff for ourselves, obviously, but mainly, open source, I think, is one really strong way to go. Even more, for example, when you actually are using a component that you are not maybe 100%, sure of whether it's successful or not. And then you can actually tap into the wisdom of the crowds, right? To tell you, for example, if it was properly implemented, if it has vulnerabilities or not, if it can be improved. Then you can also see what kind of shape that specific project may take, because maybe you created it with one purpose, but at the end, someone else, another clever developer, thought like, oh, maybe I can use this little bit or that piece and then create something different out of it that maybe you didn't envision at the beginning. So I think it's a really fun way as well to learn from others, to collaborate, to keep this alive and to keep us as well on improving yourself.
Yeah, absolutely. I mean, I can see that the question is quite open. It's both, will enterprise companies look to contribute and integrate open source software into their stack? And it's not only related to zero knowledge. I think it's a more generic one. As Deloitte, I mean, if I talk about my clients, our clients, and what I see everywhere, even governments, some governments, some departments CIOs and CTO have mandates like literally open source only software. That's what we run. There are cases, and they're common. They're quite common. So that probably answers the question if enterprises will ever introduce into their stack open source software. They already do, and they do a large scale. They do everywhere. It's everywhere. I mean, Red Dot runs everywhere. It's huge. Will they contribute? It is starting. We have done ourselves several times. Microsoft has done. It's starting more and more and more. So it's unstoppable, I think, at this point in time.
The most important part of the software that needs to be open source, or at least reviewable for stakeholders is the part that touches your data, right? So you would be convinced to use a protocol if you know that everything that can be done to assure you of that the protocol is functioning correctly has been done. And open source it takes you 90% of the way. You know that when a protocol is published and being used out in the open, there's way more chances of bugs and problems to pop up and to be resolved in faster. So
that's true for everything, Jonathan. That's true for everything. I mean, open source software means you can simply do those quality checks that you would do for your own software. I remember back in the days, like 10 years, 15 years ago, when we were at the beginning, I remember before getting into our stack, any open source software, we would run our own, architectural review checks, automated, all automated, now Sonar, etc. And you will get, some nice statistics to say, okay, these guys are writing good code.
And the beauty of it is that all that effort that you're doing and other enterprises are doing is poured back into that open source project. So you get audits continuously. This is one of the triggers for ZKProof is actually audit work that we've done in collaboration with Zcash. Before Sapling was launched, right? We were commended to try to have a Zcash audit. And that went back to the open source protocol before launch.
Well, we just hit the hour mark, and I want to thank you all for your time today and participating, and for the over 100 participants who've tuned in to listen to this specific panel. Thank you so much for joining us, especially across all of these different time zones at this very unique time where we do ZKProof Home Edition.
Thank you, Sam.
Thank you.
Thanks very much.
Thank you so much. Ciao.
Thank you. Bye.
Ciao.
Thank you all very much. We're going to, and thank you, Sam, for a great moderation. We're gonna start moving to the next session. So I'm gonna remove some panelists and add other speakers. So let me try to do that. So I would like to invite Mutu, who is a member of the steering committee, to present the next speakers. Let me share my screen.
Hi. Should I share my screen?
Just right after Mutu introduces you.
Great. All right. There was a great panel. Now in this session we have two short talks. The length of each talk is about 25 minutes. We want to keep some time for one or two questions at the end of each talk. So the speakers, keep your talk to 20-22 minutes so that we can take one or two questions. As usual, audience, please post your questions in the Q&A so that we can pick it up after the presentation has concluded. The first talk today is by Markov Kohlweiss. He's a senior lecturer in the Security and Privacy Research Group at University of Edinburgh. He holds PhD in cryptography from KU Leuven and was a researcher at Microsoft Research Cambridge in the Programming Principles and Tools Group. He works in formal verification, foundations of cryptography, applied cryptography, as well as formal verification of protocol implementation. He's contributed to the Identity Mixer anonymous credential system at IBM Research Zurich, and is a founding member of the MITLS project, now that is referred to as the Project Everest, which is a verified implementation of the TLS standard. And for this work, actually, he received the Levchin Prize, which is one of the prestigious prizes that real-world cryptography awards each year. I can also say that his commitment to zero knowledge, the community has benefited a lot. I'm part of a project with Markov on trying to give sort of a UC formulation to snarks. Today, he's going to talk about secure and private distributed ledgers, ZK, Savior, and Saved.
Okay, let's do the sharing and video indeed. Okay. So which one, how does this work? Can you see that?
While you're setting up Markov, just a quick remark. Around the 20-minute mark, I might interrupt what you're talking, and I'll say you have 2 more minutes.
Great. Yeah, I hope I make it, but we'll see. It's quite a lot of content. So can you see my screen? And because I have
Marco, yeah, we see the presenter view right now. So
okay.
You may want to change
so
to the
I tested it before. Okay, that is the first glitch. So let's see. Let's share the screen again. If it doesn't work, then let's do it without presenter view. But we tested it before and it worked with the presenter view. Okay, so PowerPoint. Okay, now you see the PowerPoint.
Yes, now it's the PowerPoint.
Now you see the presentation.
Yes, that's perfect.
And now you see the presenter view?
Nope.
Okay, perfect. So I have my presenter view locally, and you have the white presentation. Okay, let's get started. So, my talk will be about a fruitful interaction between distributed ledgers and zero knowledge proof systems. So it wouldn't be possible without my collaborators. You know who you are at University of Edinburgh, IOHK, and the Blockchain Technology Lab. A special shout out to Thomas Kerber and Mary Muller, 2 PhD students who did a lot of the research I'm going to present. So let's jump right into it. There's not that much time. So I assume some familiarity with distributed ledgers and non-interactive zero knowledge, snarks. The main kind of thing we want from a distributed ledger is consensus and kind of immutability. So once it's there, it can't be changed. And what we want from an ISIC is that we can prove statements for which we have a witness without revealing the witness. And these 2 primitives, cryptographic primitives, share like a common goal, which I want to call inclusive accountability, namely that everyone can check what is going on. And this is true for non-interactive zero knowledge. And there's a typical integration, let's call it the standard integration between the 2 systems, where you commit 2 secrets on the ledger, and then you prove properties about those secrets hidden in commitments or ciphertexts, encryptions, using the NISIC proof system. And systems like that are, for instance, Zcash, where you commit to the secrets of coins, or DAPL, where you commit to liabilities and you can prove that you can meet your liabilities, or entity secrets in Semaphore, which is a system that allows you to post one message, one message anonymously, but only once, which you can do this. You can use this for many things, for instance, for online service and things like that. So there are synergies between ledgers and zero knowledge that I think can be exploited in a deeper way. And so zero knowledge is good at hiding private information, and it has efficient verification. but its soundness relies on a trusted setup, as was also discussed in the panel before. While distributed ledgers establish consensus, but everything typically is public, and there's a lots of wasteful resource duplication, especially in Bitcoin mining. So this consensus, moreover, it creates value. So as dubious and early as kind of cryptocurrencies are, and people buy into these things, and there's lots of investment. And I think Zero Knowledge really benefited from that. So a lot of our salaries nowadays are paid by, let's say, blockchain money, but the research goes also in Zero Knowledge. So this is another kind of example for a virtuous cycle and a relationship between those two. So the question I want to ask is, in this talk, is can we gain a deeper, what can we gain from a deeper integration between ledgers and Zero Knowledge? And the next slide kind of gives a high-level overview of the story of my talk. So I will start with kind of recapping how to build blockchains or ledgers from basic resources that are quite distributed, like a random oracle, a global clock, a diffusion network, and an initial genesis block. And this will cover a Bitcoin, but also the Ouroboros protocol, which is behind the Cardano cryptocurrency of IRHK. So next, I will show how to construct a different kind of ledger, namely a private ledger, which is similar to Zcash for the proof of work setting, or it's exemplified by the Kachina protocol, a member of the Ouroboros family, which builds a private ledger in the proof of stake setting. I will not cover the next topic all that much, especially if I run out of time, but I think this is also very relevant. So this is a more powerful private ledger, which also supports private smart contracts. And we did some foundational work into this, which is the Kachina Project. So if you saw the dolls on Charles' desk in the panel before, so these are Kachinas. So both of those kind of, and private smart contracts captures, I would say, the special cases of these projects like Dapol or Semaphore as special cases. So both of those things are examples for how Zero Knowledge can help ledgers and kind of repay all the money we receive through kind of cryptocurrency funding. But another question one can ask is, can ledgers, can blockchains help Zero Knowledge in a different way than paying for research? And the idea here is that blockchains can help us build a trusted setup, which is crucial for Zero Knowledge, and that kind of allows us then to bootstrap all these nice things that are described without requiring anything else than what is already needed for blockchains, namely these four blue resources in blue up here. And crypto systems, we can, like Zero Knowledge proof systems that can benefit from such a universal setups are Sonic, Marlin, Blanc, and but potentially also other systems such as GOS16. And then further examples that I will not go into in detail are these kind of concise verification techniques using Zero Knowledge for blockchains such as Coda and Pluma. So let's start with ledgers. So ledgers implement an immutable transaction system where you record transactions, but they have to operate in quite a hostile environment. So we want to avoid any kind of trusted central entity. We want to support participants joining and leaving at will without requiring special permission and being able to both read and write the ledger. So this is really challenging environment. And I usually am quite annoyed when in a talk, a speaker talks 20 minutes about Bitcoin and then 5 minutes about their new results. So I will try not to do that, but I think it's still important to recall how Bitcoin works very quickly. So in Bitcoin, Bitcoin is kind of based on a lottery style extension of the blockchain. So miners compute hash values, a lot of them, and pick a new nonce in order to test their luck. And if they are smaller than some difficulty parameter, they can extend the blockchain. So the observation here is that more hashing power means better chance of producing blocks. And that translates into a lower probability of producing forks. And this can be, and that gives us this immutability and consensus. And this can be formalized. So an important paper in this setting is this paper on blockchain properties by Guave, Kiayas, and Leonardos, which formalized 3 properties that a blockchain needs to satisfy in order to realize a good distributed transaction ledger. So the big downside of Bitcoin is that it's not energy efficient. So that's where proof of stake can come to the rescue. So in proof of stake, we use stake instead of mining power to extend the blockchain. So stake is a kind of a measure for the buy-in of parties, and miners are now called stakeholders. And the next leader who wins this lottery is picked based on the amount of stake they have. So the probability of someone becoming a leader should depend on their stake. And this has a massive effect on the energy consumption. So Bitcoin sometimes is, the energy consumption of Bitcoin is compared to a small country, while for proof of stake protocols, it could be like, let's say, a big household or a small factory. So this is really what we want to fight global warming and stuff like that. So that's super important. So how can we get there? So what do we need? So what we start off from are the same kind of quite distributed resources that Bitcoin also uses, and we want to build a cryptographic protocol around that. So the tools of that protocol are manifold, but I will point out the 2 main ones. So that is a verifiable random function with unpredictability under malicious key generation. And the purpose here is to do this private leader election based on the party's stake. And the malicious key generation security here is to allow even malicious actors to join and not break the security of the protocol. The second primitive is a key evolving signature scheme. And that primitive is used to, after a block leader was selected, someone won the lottery, he has to sign the block. And that's where he uses the key evolving signature scheme. The key evolution allows the block leader to delete its secret key for that time slot before it even reveals to anyone that it won the lottery. And this prevents adaptive attack, which is extremely important for proof of stake protocols. So here is now a quick kind of overview of one of the protocols of the Ouroboros family, so Ouroboros Genesis. And as you can see, time is divided into slots, and time is divided into epochs, and epochs are further divided into slots. So for the operation of the protocol, we look at 3 epochs, epoch -1, epoch -2, and the current epoch. And so how does this leadership election work? So we have some blocks, so a blockchain already, and we want to extend it in the current epoch. So for that, we first fix the stake distribution, and that is taken from the blockchain as it is in epoch -2, so as it is in the past. So that fixes who is eligible with which stake to the leadership election. In epoch -2, we obtain some public seed, some public randomness, and that is already computed using the VRF by the leaders of this epoch -1. So the stake and the seed together feed into, and it's important that one party here is honest. So these 2 pieces now feed in the leadership election in the current epoch, and similar to Bitcoin, you have to get a VRF value, so a random value that is smaller than your stake to win the leadership election. So that's Ouroboros in a nutshell. The result of this protocol is that whether you become a leader or not is quite random. And then we do a combinatoric analysis to show that in most cases, the protocol behaves correctly. And this gives us then these three ledger properties that I mentioned, blockchain properties that I mentioned before. So this was now a very quick wrap-up of the kind of non-private Ouroboros proof of stake family. So now I will move into privacy territory, and we start using zero-knowledge proofs. So that's the Ouroboros Cryptogenius protocol. So it realizes a different kind of ledger functionality, namely a private ledger, which has the same consistency and liveness guarantees as a ledger, but parties here have now a private view into the ledger. So for instance, the green party only sees the transactions that it created or received. And this is similar to Zcash, where you can, for instance, spend money to an anonymous public key. And so you don't really know whom you're sending the money to. Similarly, other parties have their own private view into the ledger. And in particular, if the adversary doesn't control any of the parties, all he can see is that a transaction was happening from someone to someone without knowing the parties or the amounts or anything else. So how can we realize this? So this will be my one slide summary of Zcash. So in Zcash, there are coins, and the coins are represented on the ledger as commitments that hide the coin secrets. And when a coin is spent, we reveal the nullifier of that coin. And the important property that for anonymity is that nullifiers and coins are unlinkable. And this is achieved, this is precisely what is achieved using zero-knowledge proofs and snarks. So let's spend one coin, let's spend the green coin. So what happens, we create a new coin commitment with the public key of the receiver and some new randomness R. And we reveal the nullifier for the green coin, again, in an unlinkable way. And we transfer the randomness using a public key encryption scheme to the receiver, who needs that to spend it on. So this is really kind of the core operation of Zcash. And this is great for privacy because it guarantees unlinkability. But it's still not great for energy efficiency because Zcash relies on Bitcoin, so it gets all the kind of energy waste that we know from Bitcoin. So what we want to get is really energy efficiency and privacy. And this is really not that easy because for a proof of stake, we need some kind of stake distribution. So we have to extend the cryptographic tools of quite a bit. So what we use is, of course, snarks, but we need some tools that we can use with those snarks. So the first is a pseudo-random function with malicious key generation. So this is in some sense weaker than a VRF, a verifiable random function. But by combining it with a snark system, we get kind of something more powerful, a very flexible VRF where we can prove whatever we want about the inputs and outputs of the VRF. And this gives us this possibility to do a private stake, private leader election. So the second building block, and that replaces the key evolving signature scheme, is an evolving key pair. So what this will allow us to build is, in some sense, an anonymous key evolving signature scheme, where we don't reveal who is signing. And the way to do this is to use snarky signatures. So a signature is a proof of knowledge of the secret key. And in addition, we can update the secret key to get this adaptive security property. And as an extra bonus, because we already have a snark verification from the leadership election, we essentially get the signature scheme for free, at least at the verifier side. So how is this used? So we start with the coins that are then represented, like kind of hashed into a Merkle tree as the stake distribution, but we keep all the coin commitments. So that's step one. So step two is we collect the seed, collect randomness in epoch minus 1, but we have to do the anonymous stake, the anonymous leadership election in that epoch as well, which we will see works as follows. So the third step is to do the leadership election. And this is similar, except that we hide the secret key, the randomness, and the value of the coin inside of the snark. So that's our strawman solution, which has a few a few weaknesses or things that we still need to fix. One is that even spent coins can still be used in leadership elections because there's no link between the nullifier and this leadership election. So the way around that is to reveal a new coin and a nullifier. And then the new coin can be used for spending or for further leadership elections. So the problem is that this new coin, the randomness of that new coin, is picked in a way that is no longer independent of the stake distribution or the seed. So the solution there is to compute that coin deterministically. The next three problems are related to adaptive security or forward security, so to say. So if an attacker corrupts a user, then he can learn the randomnesses of past coins, and that would allow computing nullifiers. So the solution there is to delete the randomness. And moreover, if he learns the key of a party, he might decrypt the randomness from the public key encryption. So you have to use something like forward secure encryption with a delayed corruption model. And we also need this key evolving key pairs to get key evolving signatures, anonymous key evolving signatures. But if we do those fixes, we can actually prove that this works and that we get a private ledger. So this is this kind of first part of the patch where we
2 minutes.
Okay, great. So where we get this coin commitments that can then be spent onwards, and this needs to be computed in a deterministic way. So the advantages here are now that we're both energy efficient and private, which is kind of are the two biggest problems, I would say, that we have besides defeating the coronavirus. I discussed all the other examples for the uses of zero knowledge, so I will go fast here. So the last 2 minutes, I want to talk about how Ledger can help us get a secure reference string. So this is mining for privacy. So, and this is, you can find this on ePrint. So mining for privacy in some sense is an exhibition to save the snark. So another kind of Extinction Rebellion pun. And what it essentially is we incentivize miners to participate in a massive structured reference string ceremony. The types of referencing that we can update are easily update are reference strings with monomials in the exponent, for instance, Sonic depicted here. But if we go two-phase, we can also do cross 16. Also, we don't get the universality, which is quite nice. Here is kind of the construction that we do. So on the left is the real world, where every miner applies a permutation on the old reference string. On the right, we have like a biased structured reference string functionality where the advisor can provide a permutation which is applied to the trapdoor, for which we then get the final structured reference string. And that reference string can be used after some delay, after sufficiently many updates have been applied. How long is that delay? So we can compute it from these blockchain properties of chain quality, common prefix, and chain growth that I mentioned before. Chain quality gives us that some honest parties will participate in the mining. Common prefix will give us that after sufficiently many blocks, we will have agreement on the reference string, and chain growth tells us that the blockchain actually grows, and we get both of those properties. So that's the formula for how long we have to wait. We also did experiments. So if you have a lot of corruption and corrupted state, mining power, then
Markov, you're running out of time.
Okay, good. It says 2 here, but I guess that was the setup problem. So so to wrap up, so it's 3 months if there is a lot of bad stake, 3 days if you have a reasonably secure blockchain. So this is kind of the summary of what I did in the talk. And I also want to mention that we are working on implementing this. So this is our performance number for Sonic. You can go on GitHub. We chose it because its performance is kind of favorable for the characteristic that we want, like proof efficiency and proof size. So it lies somewhere between GAUSS16 and Marlin. It relies on the helper model. So this is a caveat, but for large batch sizes, we get also very good verification times. And the helper can also run on the blockchain as part of the mining process. So I think this is a very nice setting for Sonic. So I think I will not have time to describe our kind of foundational work on private smart contracts. But this is Kachina, and we did, for instance, a proof of Zcash as a private smart contract. So you write, first you write the idea of smart contracts, then you write a smart contract that emulates the Zcash and kind of what Zcash does, but in an honest but curious way, and then you compile it into a private smart contract that works in a very adversarial setting and only relies on zero knowledge, which you can then bootstrap using mining for privacy. So this is kind of our bootstrapping story for private smart contracts. So that's what I have.
All right, thanks, Markov. I think we are like running out of time to have a question. There are a couple of remarks and comments on the chat. Please feel free to answer after. They're mostly related to motivation of proof of stake as well as privacy. So with that, thanks. Let's all thank the speaker. That was a great presentation. Thanks, Markov.
Thanks, guys.
Thank you, Markov.
So I will stop
sharing. Do you mind stop sharing your screen?
No worries.
Yeah, thank you. So we're going to bring John. Oh, one second.
You want to bring John to the panelist?
John is here already, so you can go ahead.
All right. So it gives me pleasure to introduce the next speaker in this session, Jonathan Roush. He's no stranger to ZKProof. He's the co-founder and CEO of Kedit, helping enterprises leverage their data using privacy-enhanced techniques and zero-knowledge proofs. Before that, he co-founded a blockchain security company that was sold to Digital Asset Holding, co-founded in the Israeli Bitcoin Association, co-founded Bits of Gold, the leading Bitcoin exchange in Israel.
All of this with my co-founder, Ruben Arnold, who's also in, you can see. I'm in Paris and I'm in Tel Aviv.
And on a personal note, of course, I have to point out that, the whole ZKProof, owes a lot to Kedit, steered by Jonathan Roush, for promoting this and funding this and supporting this in more ways than, just monetary. And with that, he's going to talk about some new, really exciting stuff from Kedit, combining advanced cryptography in enterprise products, showcasing Kedit for Excel.
Thank you very much. So I will present this screen. Just a second. All right. Can you see my screen?
Yes.
Excellent. So thank you very much for the introductions. We don't have a lot of time, but enough to thank everybody. But I'd like to start with introducing Ruben. As you said, my co-founder at Kedit and our executive chairman. Ruben, do you want to start?
Yeah, it's a real pleasure to be here, and unfortunately this year it's an online meeting, but it's so successful that we tend to forget this is online. It was such a pleasure being last year with you. So we have pictures from the couple of last years, just to remind you good memories, good souvenirs from MIT 2 years ago, for the first edition of ZKProof, and also last year in Berkeley, and also in Amsterdam we had also a small edition a few months ago, and it was such a pleasure hanging with the community there and meeting people in person. Hopefully, in the foreseen future, we'll be able to do that again. So we're building that.
Thank you. We're very happy to be supporting ZKProof year after year, and what we're trying to achieve here is bringing to the community whatever we can for the adoption of zero knowledge proof and privacy techniques in general. Of course, we're a company, so we have our commercial approach to the market and going to enterprise, etc. But the work here is exactly about where do we connect with other players in the industry, and how do we collaborate and combine our efforts. Do you see what I see? It's loading, but no screen, right? So I'll just skip this one. So like I said, our team is really dedicated to this. So little shout out for the CADI team involved in the ZKProof effort: Aurel, Aviv, Daniel, Eran, and Yao. So year after year, we started with 2 years ago with finding what can we bring to this effort that could make it possible to have collaborations between different zero knowledge proof teams. And what we found was ZK Interface is that proposal, and we're very happy to see that it has been useful. It's picking up pace. In particular, I mentioned it in the panel before. There's now a group of very advanced cryptographers and hands-on engineers that are considering ZK Interface as the or some form of ZK Interface as the representation of circuits for a very large DARPA project. So this was our contribution back then, other than trying to push the entire event. But in general, what we aim to do as a company is the opposite: is bring this spirit, this community, and the trust that we generate from looking at each other's schemes and diving into the details of the technology. Bring that to the market, and when we bring that to the market, what we need to do is actually dumb it down. So we need to make sure that the tools are very useful, and this is what we've been trying to do, and this is what I'm going to focus on in this talk. We're trying to lower the bar for people to be using advanced cryptography. So what does that mean? We can talk a lot about trusted setup and and SGX versus zero knowledge and even MPC versus homomorphic encryption, all those different techniques. But from the user's perspective, when they're faced with a case where they have sensitive data and they need to handle this data, today they don't have accessible tools to do that gesture of collaborating on private data. It's not in the hands of people, other than maybe the shielded transfer of tokens on Zcash, but you don't have for enterprise use case, or for use case where the data is your client list or sensitive lists, a way to make use of these advanced cryptography. And what we realized is that the barriers between these different cryptographic techniques, zero knowledge proof, homomorphic encryption, private set intersection, multi-party, all these techniques can be combined in interesting ways. And if we do it well enough, from the user perspective, all they need to know is that their data is safe and they can reach the result that they wanted. So just a small copyright note: we are not part of Microsoft. When I present Excel this is Excel is Microsoft's product. It's not our product. And if I happen to say Kedit for Excel, what I basically mean is Kedit for spreadsheets. But the product itself is going to be available on the Excel add-in platform. So let's talk about a use case. Where can you be using this tool? So let's say that you have, we actually did this. We went to one of our investors, and they have invested in many other companies, and they were struggling to find a way to make these companies collaborate, and in particular collaborate on their client data. So you can think of one company having many clients in some geography, and another company having maybe some subset of these clients. And if they join forces together, they could put a commercial offering on this joint set, and it would profit for the two companies. So you have a sort of overviewing portfolio manager that wants all these companies to collaborate, but there's no legitimate place to keep all this client data together. It's very sensitive. So if we take an example, if Ruben represents one of those companies and I'm another one, we have the decision power to decide to verify if our clients are matching. We really think that it's a strategic move to see if we have overlapping clients between us. But with all the goodwill, I cannot send my list of clients to Ruben, and Ruben cannot send his list of clients to me. You can't, right? You can't.
I cannot do that.
So what do? So this is my Excel. It's a list of clients. His Excel is a list of clients with also their emails. We both installed Kedit for spreadsheets. And this is what you see on the right. It's a little add-in. What it has inside is all of the cryptography necessary to compare lists without sending data between us compiled to JavaScript. So this is all running locally on my machine. I have my Excel, I have my add-in. I created a comparison group with Ruben, selected the list of clients that I wanted to compare with, and I pressed find matches. Ruben did the same on his side. And after we click that, we have a column that tells us, okay, these clients are matching and these clients are not matching. And from there, we can continue with the business process of collecting all those that are matching and approaching them together with a joint offering. Now, under the hood, what happened, and I'm not going to go into the actual protocol. This is called a privacy preserving link. So RL, I'm forgetting the name, PPRL, record link, sorry. And the idea is, how do you manage to find which record match in two different databases without sending those records over to anyone? The problem PPRL was actually stated a long time ago. So I recently rediscovered that that's the name of the problem. But from a user perspective, they're trying to do a private set intersection. They want to try to find out if they have an intersecting set with the other party. So there's the first step that happens locally, which is taking a hash of a row. Second step, still locally, of taking that hash value and putting it on an elliptic curve. The idea there is we want to prevent Kedit itself from being able to brute force the value under the hash. But we have a mechanism to bring the different sides of the different rows from John and from Ruben to a canonic form that will tell us if there's a match or if there's no match. This obviously for anyone from the Zcash community, Kedit learns a lot in this process, right? We learn, for example, the number of rows, or there's a lot that there's trust on the metadata that's being put in Kedit's hands. But we found that on the ground, when people want to be using these techniques, that's the level of privacy they need. They need tools that keep that data from going to anyone in the ecosystem, and they run these tools locally. So to give you an example of where this can go, a few use cases. Ruben, do you want to present some of them?
Yeah, sure. We can do variation of the use cases. For example, here what we're showcasing is a blacklist manager. On one side, we have a player managing a blacklist. So, for example, it's bad payers, and on the other side, we have people trying on the network on the comparison group trying to test names, and we have real use cases from real world. For example, in France, they were talking about setting up a database of bad payers for rent, bad renters, and the way they want to do that is very old-fashioned, right? Centralized database with access to professional people to it, and it raises a lot of concerns regarding privacy. And with this kind of tool, it allows people to check if a name is in the blacklisted list or not, and no one is sharing information. So on the side of the blacklist manager, you don't share the whole list, of course, and on the side of the tester, you don't share the name you're trying to test. And it's a way to use this technology for blacklist management, for kind of regulation. Another way of doing that, it's a very interesting one, is instead of flagging the names on the spreadsheet, is to have a total of flags. So here, the 6, it doesn't apply to the first name. The 6 is a total of all flags in the list. And for example, it allows this tool to be kind of GDPR compliant. I'll give you an example. So for example, in the certification market, so the certification is when a vendor like Microsoft or Google or whatever is training people and certifying them on the technology. This certification is attached to a person, not attached to a company. And on the other side, you have service providers, let's say like Accenture or big groups, having employees, and they need to have the employees certified on different technologies, but the certification is attached to the employee, not to the company, and they don't have a view of all certified people by technology unless everyone just gives them this information. But in the real world, it's very difficult to maintain a database for Accenture, for example, or for others, a database of who in my employee population is certified by such and such a technology. And we understand that there is a lot of turnover in the company, and there is a date for each certification until it's not valid anymore. So it's a problem. And if you want to solve this problem, a way to do that, to give a big picture of not who is certified, but how many people certified by geography or by company do I have, is this way, is to match between two lists. On one side, the list of certified people by the vendor, on the other side, the list of employees by the service provider. And by matching those two lists with this kind of tool, you can get a number, and this number is number of people certified I have as a service provider at Microsoft, for example, for a specific technology. And not doing that is not possible because you're not GDPR compliant. You cannot just share the list of people on that matter. You want to take this one, John?
Sure. So maybe the last one is a bit COVID related. So this is the same principle, but applied several times. Here you have people lying in beds, unfortunately, in hospitals. You know, this is their list. we invented this this list for this presentation. You have their blood type, their age range, their gender, and there's a pharmaceutical firm that's looking to find a particular profile for a clinical trial. And the problem is that, of course, they're a pharmaceutical, they pay for these trials. So there's a strong incentive for hospitals to say that that person matches the profile, even though maybe they don't really match, and the pharmaceutical will discover that too late. So there were cases of fraud where you had hospitals getting paid for many patients that were not actually a fit to the criteria of the clinical trial, and that the whole process of selecting people is very costly. So what we do here is apply the same principle of sharing matching lists with on one side the criteria itself, and on the other all of the different fields match against the fields on the left. And once you do this comparison, this is in a way locked. So you have you can see that here this row Dottie Healer is a match for blood type, age range, and gender. So this is you can even calculate a score on your spreadsheet, 100%. That means that this line, this row, is linked with all the different fields, and it matches the criteria of the pharmaceutical firm. But more importantly, the hospital cannot go back and say, oh, now that I've learned what is your criteria, here's the list of people. They never learn the criteria before they press the comparison. Of course, after they press the comparison, they can understand what were the criteria from the data that comes back. But before that, they don't have access to what is going to be selected. So this is just a tip of the iceberg of use cases that we've seen in the large. The idea here is the underlying technique. We can to those interested, you can send us an email at info@caddy.com, and we'll give you what's going on under the hood. There's a combination of hashing, encryption, and MPC. This is, as I said, running with Cadit as a trusted matcher, in the sense that we don't see the underlying data, but we do provide the service as a SaaS, as a central provider for these comparisons. And this is what our clients want. So they want an add-in that they can easily connect other people and compare. And we suggest that if this is of interest to play a bit with these tools, again, contact us and get the very initial versions. This is going to be very soon released on the Microsoft add-in shop. So
it's also relevant to say that this project is COVID related. In fact, we use all the use cases presented here are real life use cases. We worked on these use cases with clients, real clients, not with Excel, not with spreadsheets, but with bigger systems deployed into their IT systems. And when we faced as a team 2 months ago this COVID crisis, we thought, what could we do in order to as John just said, to lower the bar of adoption for our product? And it came from a business reason, right? We knew that it would be difficult to reach out to decision makers in the coming months. So we wanted to lower the bar to test and adoption, and also because we wanted to give a tool for for all those use cases that maybe are smaller, are too small to deserve an IT system dedicated to solve them. And we had some incomings from a municipality close to our office saying, we want to compare the list of people with special needs in COVID time to bring them food, etc. We cannot do that. Our legal team doesn't allow to share lists because of regulation, etc. So we saw that, okay, if we can provide a tool like that to our community around, and they can just take this capability and solve the problem, it can be, for us, something great we can take out from this COVID crisis. So we from remote, of course, we just talked with the team and agreed to have a first version of it. So this is the first version, and it's important for us to get your feedback. You as a very valuable community to us, we'd like to to invite you to use this tool, to get your feedback on this tool. Of course, we'd be happy to assist you to deploy this tool, to do the setup. So it should be easy, right? It will be deployed on the Microsoft platform. But if you need any help, we'd be happy to assist with that and to get your feedback to improve these tools with time. So this is our small ask at the end of this presentation. Just use it.
We already had
John, just 1 second, 2 minutes. Okay. 2 minutes.
I'm finishing just now. We already had the first asks saying, "Hey, what if this field was a number, and we used homomorphic encryption to add with other people's numbers?" And it turns out that under the hood, our platform actually already supports adding numbers in with homomorphic encryption. So it seems like this way of presenting an interface to users already steers them in the right direction. This gesture of collaborating on private data, they understand it in a bit better, in a bit more direct way, and from that gesture, we believe that we can add more and more advanced capabilities. We know there's already a company that did similar things with secure multi-party computation in the past, and we believe that this is something that should exist in the wide market. Tools that let you use directly all of this cryptography that we're talking about. Of course, this being a zero knowledge proof event, there's talks about how does zero knowledge connect to this, and you can immediately imagine if I prove that my list was an addition to my previous list, that requires commitments, and there's a whole conversation there that we'll be very happy to have also with people from this community. So this was a sort of wrap up. Again, to say
it's free. It will be free on the platform. It's important to say, right? It's not.
Yeah. This is a free tool, right? So again, that big thank you for having us and having us present this tool, and to all of the participants in this event. That it was a very insightful series of weeks, and we loved every bit of it.
I'm looking forward to see you in person next year. Thank you, Mutu. You're on mute.
You're muted. You're muted, Mutu.
Thanks so much, John and Ruben. Sorry, Ruben, I didn't quite introduce you, but you are an active participant in this community. I want to put in a couple of questions here. I'm picking and choosing. Sorry, I'm not taking any favorite sites. I'm just picking a couple of questions here. How do you attest to the data, right? I mean, this is an important question. Like, is it incentive based, or can you do some kind of input certification, right? That'll be a nice feature.
I'm sure that question was asked right before I talked about the expanding to zero knowledge, right? So yeah, obviously, if one party becomes nasty and starts putting data that they manipulate into the Excel, and that's a very easy thing to do because it's Excel after all, and you can do whatever you want with it. So those use cases today are not covered with the tool. This is a basic gesture of comparing sets, where at this stage, the parties that are involved in a comparison group have an incentive to put the right data, and that's the model that we work with. Further down the line, it's pretty direct to see how you can show properties of the data that you're not sharing. In particular, the evolution of the data if you have commit points. And this is, it's the exact same techniques that we've all been talking about, commit and proof and and how do you take the commits outside of the influence of the prover, and then how do you verify the proofs, in a trusted way? It's just that here you're going to have that available to your surroundings. You'll be able to prove those things to anyone that you interact with that can open an Excel file.
Okay. Maybe one last question, maybe very short answer to this question. I'm assuming there is some form of a multi-party computation protocol for private sector intersection or privacy preserving record linkage over here. Is this based on like something that's published? Is it going to be published? Is the information on what protocol, what proof of security available somewhere?
So right now it will be available for people who directly contact us. It hasn't been published yet. Elements of it are parts of standards that exist in IETF, and so the building blocks of this is pretty standard. But we had to take trade-offs so that we can have a central matcher that still doesn't have an ability to brute force the system. And at some point, the underlying protocol will be published.
Okay. Thanks, John. Thanks, Ruben. That was a very nice presentation. We want to take a very short break. There is a great panel coming up. So let's all step out for 5 minutes.
Thank you.
All right.
Thank you, everyone.
Thanks, everyone.
Yes, sounds good. 5-minute break to refresh yourselves while we set up for the panel. Thank you all. Thank you, Mutu. Thank you so much for
all right,
chairing this session. Okay, I'm going to invite, yep, absolutely. Going to invite the next round of panelists.
Hi, Daniel, can you hear me?
Okay, sorry everyone. My Zoom suddenly just froze and I was out of control. So I guess now all of the panelists are on screen. It's gonna be like 2 more minutes until we get out of the break. So I'll start sharing my screen in a second. Thank you all for joining. I think everybody is very excited for this panel.
Hi, Kristen. You weren't there yesterday. We went through a bunch of stuff, but you're just going to have to deal with it online.
No problem. I joined you guys briefly, but I had another meeting going on at the same time, so it was hard to listen to two conversations at once.
Okay. So I don't know if you saw the draft, but your name is in some places.
Yep.
But pretty much we're going to run it so that somebody wants to weigh in, they can, even if I didn't direct the question to them. Okay. I think we have an hour. We're supposed to leave 15 minutes for questions. Is that correct, Daniel?
Yes.
Okay,
there will be questions coming up in the Q&A, and you'll be able to actually ask those questions yourself, or read them.
Okay. I'm here just a panelist. I'm not going to film what my opinions are, if I can help it. I took this anti-opinion pill this morning.
What if it stops working in the middle of the panel?
That's always a possibility. It's never worked before, but I have hopes.
Is there a test for it working?
I don't think I've ever been a moderator for a panel.
Congrats.
These people are supposed to shut up, right? Just ask questions. I will attempt my best.
I think everybody would also like to hear from you, Shafi. So, okay. Oops, sorry about that. So it's basically 5 past. We are now back from our break. More people will be probably joining throughout, but I would just like to say that we're very excited about this panel. And it's going to kind of highlighting the vision of ZKProof and of the field in general, and we hope you all get the most out of it. In the panel, we'll have Joshua, Yuval, Christine, Chris, Vinod, Gobi, and moderated by Shafi. I'm going to start recording the session, and Shafi, please go ahead.
Okay, so thank you for inviting this panel and for inviting me to moderate. So the first thing I'd like to do is to introduce our panelists in the sense that they will introduce themselves. And I'm going to just go in order of people on my screen. So the first person is Joshua Barron from DARPA. If you could just say like a minute introduction or less, who you are and what your interest is.
Yeah, so I'm Josh Barron. I am a program manager at DARPA. I run programs in cryptography, privacy, and anonymity. So we had a privacy program called Brandeis, where we looked at things like homomorphic encryptions for multi-party computation. A program called RACE, which is on anonymous communications, where we're doing an interesting kind of specific application of MPC. I have a new program that just started a couple weeks ago called CIV in Zero Knowledge, and a program that actually we announced a week or two ago called CSL, whose name is actually missing right now, and it's about using things like differential privacy and cryptography for machine learning.
Great, and the next on my screen is Vinod. Can you introduce yourself?
Muted.
You're muted.
I'm Vinod Vaikuntanathan. I'm an associate professor at MIT. My interests are in cryptography and most recently in the problem of encrypted computation, which includes sort of homomorphic encryption, secure multi-party computation, and so forth. I also sort of, there's one sort of big tool in my toolbox, which is sort of lattices, and I use sort of lattices to construct many of these sort of cryptographic systems. But broadly, I'm interested in sort of all of cryptography, even more broadly, a little bit of machine learning, a little bit of quantum computing, a little bit of everything, science.
Kobe.
Hi, I'm Kobe Nistin from Georgetown University, where I'm a professor of computer science. I mostly work on privacy, differential privacy. This is for about like the last 17 or so years. My background before that is in cryptography, secure multi-party computation. I'm still interested in the relationship between privacy and secure computation. Currently, I work on differential privacy a lot in the context of machine learning, but also with respect to questions of distribution. And I'm also interested in understanding the relationship between the notions of privacy that were introduced in computer science and those that we find in ethics and in the legal code.
Yuval?
Hi, I'm Yuval Ishai. I'm a professor of computer science at the Technion. I work on different areas of cryptography, a bit also on complexity theory. I'm always fascinated to see how ideas that come from theoretical cryptography and the theory of computer science at large find unexpected applications, especially in practical domains. And I'm also constantly feeling like there are many interconnections between different types of advanced cryptography with relations to the other areas I mentioned, and I'm very happy to be on this panel. So thanks for inviting me.
Chris Pickard?
Hi, everybody. I'm Chris Pickard. I'm an associate professor at University of Michigan in Ann Arbor, and I work on cryptography. For about the past 15 years, I've been trying to kind of redo cryptography, all of cryptography based on lattices. So that includes basic things like encryption and signature schemes, all the way up to very advanced, fancy crypto like fully homomorphic encryption and everywhere in between, zero knowledge protocols and things like that. I also like to do some programming from time to time, but I mostly work on the more theoretical aspects of these topics.
Shafi, you're muted.
Sorry, last but not least, Kristen Lauder from Microsoft.
Hi, I'm Kristen Lauder. I'm at Microsoft Research. I'm a partner research manager and principal researcher there, as well as I'm an affiliate professor in mathematics at University of Washington. I'm a mathematician by background. I was actually a professor at University of Michigan before coming to Microsoft. I first worked on elliptic curve cryptography. So I work on all of kind of the mathematics of cryptography, bringing elliptic curve cryptography into our Windows products as of 2005. And then I worked on what is now called post-quantum cryptography, introducing supersingular isogeny graphs into cryptography as a hard problem, which is now used in the post-quantum world, and then turned to homomorphic encryption. So the last 10 years have really been working on homomorphic encryption at Microsoft, both developing our libraries, so the SEAL library for homomorphic encryption, but then also standardization efforts in collaboration with the community, including Vinod, who's on the call. So at Microsoft 3 years ago, we launched homomorphicencryption.org, which is a very wide, industry-wide community to standardize homomorphic encryption, and we released our homomorphic encryption standard 2 years ago. So that's taken up a lot of my time recently. And just this week, we announced our first commercial product based on homomorphic encryption, built on the SEAL library. And we announced it at Build. It's a private prediction, ML private prediction service in Azure ML. So nice culmination of all that work.
Great, sounds exciting. So I want to move on, and I guess over the last 5 weeks, the Zero Knowledge Conference that you have been attending met twice a week, 2 discussions a day. And if I sort of looked at the talks overall the whole time, they exhibited a very strong connection between theory and practice that has emerged in zero knowledge over the last few years. And I guess it's due largely initially to the commercialization potential of blockchains as a platform for cryptocurrency and micropayments. And now I guess it's moved also onwards to the use of zero knowledge in as an auditing mechanism in a variety of applications. So my first question is to Josh from DARPA. You mentioned the SIG program, and I guess the official title is Generating Zero Knowledge Proofs for Defense Capabilities. And I'd like to find out sort of where do you see the primary importance of zero knowledge in the world of DARPA, in addition to the things I've mentioned? And what made you decide to run this program?
Yeah, so I mean, I guess as a step back, right? I mean, the purpose of DARPA is to prevent or create technological surprise. And I think the last, obviously zero knowledge is not a new technology. I don't think I need to tell this panel that, but the last 5 years have shown the increasing applicability, like really concrete use of zero knowledge. And if we look at them, they're largely for cryptocurrency type transactions. The size of the circuits they're used for are small-ish, so kind of low millions and downwards. And then there's a lot of technology specifically to make very succinct arguments and make them very fast verifiable. And it's not 100% clear that that's necessarily where the need would be for like a defense application. So as an example of like a really flashy example, I don't think this is hardly going to be the only thing we're going to do within Civ. Could I give a zero knowledge proof of vulnerability? Which when you kind of think about it is actually a very specific kind of zero knowledge proof of computation, right? So because you have basically some certificate, some path within some computational trace, and you're trying to prove its existence without revealing kind of what it actually is. You know, circuits of that kind or other kind of more plain English things that you might want to prove in zero knowledge would ultimately become very, very large, potentially. Large enough that the kinds of superlinearity that you see in proof of complexity for snarks may or may not be appropriate. So the program is really trying to do 3 different things. The first is, well, I described it as describe the world in NP. Take problems that are kind of real world interesting, and we're just constrain that very, very broadly, and essentially put it in the kinds of format for which you could give a zero knowledge proof. So literally, it's like take something and describe it as a Boolean circuit or an arithmetic circuit or an RLNCS instance. So that's like one task area. The second task area is, okay, cool, given now that you have that, make a very efficient proof. The distinction between us, I think, and what, again, you see in a lot of the cryptocurrency world is succinctness is not necessarily what you need. There are certainly any number of potential GOD applications where maybe it does take a long time to prove it and a lot of bandwidth, but you're only proving it once. So like that's okay. And, you know, we're looking for kind of max linearity across the kind of prover verifier communication space, especially because, again, the kind of statement instances might be very large. So that's 1 and 2. And then 3, it would be, I think it's hard to do a crypto program today without at least like struggling with the notion of being post-quantum or plausibly post-quantum. So we're looking in our third area to reduce the asymptotic complexity of current theoretical constructions in post-quantum. So Chris has a fantastic result in getting NISIC from LWE. The underlying asymptotic complexity of that is large. And so like, for instance, could you make it like orders of magnitude smaller to the point where it would even be, you know, efficient for some definition of efficient? So that's what we're trying to do.
Okay, great. In fact, your answer is leading to my next question, which is you mentioned the third sort of track is focusing on post-quantum zero knowledge. Looking again through the talks that were presented in the last few weeks in the zero knowledge workshop, there's a bunch of snarks people talked about based on bilinear assumptions, Diffie-Hellman, due to efficiency considerations most largely, and maybe the familiarity of the people who are working on it. So I wanted to turn to Chris. Since you have this scheme about LWE-based non-interactive zero knowledge, I was wondering if you could give us your opinion about the potential for efficiency and how those schemes, snarks, may develop in terms of efficiency comparison to the number theoretic or the non-quantum resilient primitives.
Right.
This could be based on your knowledge of the past or clairvoyant into the future.
Right, good, good. So it's just as a bit of context, the zero knowledge proofs that we are probably all in the audience familiar with are all pre-quantum, or they could be broken by a quantum computer. So this, you know, if a big quantum computer ever gets developed, then people would either be able to prove false statements, which would be really bad, or they could violate the privacy, violate the zero knowledge of proofs that other people give, which would also be very bad. It's a bad situation either way, or both. So what we are looking at into the future is, can we, you know, build zero knowledge protocols for post-quantum cryptography, so that you know, that would be secure even if the adversary had a quantum computer that was trying to break the privacy or prove false statements. So just last year, we gave the first non-interactive zero knowledge proof based on a standard post-quantum assumption, which is called LWE, learning with errors. It's extremely inefficient. Somebody asked, how efficient is it? Is it practical? And I could only respond with the laughing, crying emoji because it's just absurdly inefficient. But people care about a lot of different efficiency metrics. They care about what's the prover's running time, what's the verifier's running time, what's the communication, the length of the proof, all of these different things. Can it be batched and so forth? And then they care about, the security. What kind of security assumptions do you have to make? Can you use a random oracle? Do you need a trusted setup? Do you need an untrusted setup? All these different things. So, with regard to snarks and things that are put on the blockchain and so forth, these days using pairings and other fancy math, we don't have anything like snarks right now from any post-quantum assumption. I guess apart from, if you use very generic tools with random oracles and things like that, but they won't be efficient practically or even very much theoretically. However, there is a lot of progress. Like every year, there's a few really cool papers that come out in crypto, Eurocrypt, or things like that, that make a really significant leap forward in terms of the efficiency of proofs for certain kinds of problems, certain relations, different kinds of circuits that people care about, cutting down the proof length by a lot. One thing that hasn't been done too much is to cut down the verification time. So for snarks, people really care a lot, at least in the blockchain space, about verification time. They want a really fast verifier. They don't mind too much if the prover is, moderately slow. Right now, we don't really have anything aside from pretty inefficient generic techniques to really make fast verification. So I think that's one of the frontiers that we, need to spend more time thinking about. And there are some theoretical barriers to getting very fast verification, where you have to assume, much stronger cryptographic assumptions that aren't, not falsifiable as they're called. So, we don't really have an idea of what kinds of assumptions might be reasonable to make that would allow us to do very fast verification. So that's something kind of, if I were clairvoyant, I would start to think about what might be coming down the road in that direction. But there's been a lot of really interesting work on all those other aspects of the proofs that we care about, the efficiency of the prover, the proof length, and assumptions, and so forth.
Great. So I guess now I want to go broader from thinking about zero knowledge and isolation, since our panel represents, as you saw, a range of expertise on other advanced privacy-enhancing technologies like pleomorphic encryption, multi-party protocols, differential privacy, private information retrieval, function sharing, private set intersection. And I think people on the panel represent also some people who actually came up with the most, either the definition of the scheme or of the primitive or the most advanced instantiation of it. So arguably, some of these primitives can take advantage of the data revolution more broadly than just zero knowledge proofs. And I wanted to touch on the potential of interaction of these technologies with zero knowledge. In fact, there's a lot of questions that come to mind. I guess the first one is the deployment of zero knowledge from theory to practice, in the sense that a lot of schemes have been developed with a lot of attention on efficiency, is kind of surprising. Blockchains are part of the reason, the fact that microcurrencies, cryptocurrencies have been on the rise is part of it. But the same thing has been for differential privacy. It's sort of a fairly recent field of study, and yet you hear about it everywhere. Lots of companies are talking about how they're going to make their machine learning differentially private. So I was wondering, this is sort of less technical and more opinion. Why is that, or why, or what do you see the future for other technologies? So Kristen, you mentioned standardization as being part of what makes theory into practice or going into deployment. Can you tell us a little bit about the FHE standardization. Just a word, the zero knowledge standardization started really as a follow-up to the FHE one. Because I know this because I was involved in it, in the creation of it. And I'm curious, what's your opinion about how much the standardization effort for FHE has made it sort of, let's say, make Microsoft go from a theoretical study to launch a product?
Well, I see standardization as a key part of transitioning from theory to practice for any technology. And actually, so far, our standardization effort has not had any effect on our productization. In the long term, it will, but not in the 3 years that we've been doing the standardization. So I actually have been, been in Microsoft more than 21 years now, and I worked on standardization for other technologies first. So I worked on standardization for elliptic curve cryptography in the early 2000s and had a lot of experience with professional societies such as IEEE and other consortiums that launched elliptic curve. And the way I think about it, the way I like to explain it, I mean, even to the general public, let alone computer scientists, is that you're going to bring cryptography, some new cryptographic primitive, basically some new hard problem in mathematics that no one knows about, no one really wants to know about. And you're going to introduce some new system, and then you're going to ask the public to trust it. And you're going to say, hey, you should use this because it's secure. And how do you do that? You don't expect people to start learning mathematics and understand that these systems, why they're secure. You do it by creating that community of experts who agrees, and this is not just academic experts, not just people that are publishing in certain conference venues, but a broad coalition of experts who are researchers in industry, government, and academia. You bring them together to decide on what they commonly agree is the hardness of some underlying problem, have discussions, have fights, whatever it is, but in the end, come up with some minimum characterization of how hard are these systems, how should we set the security levels, and then once concrete security levels are kind of understood, then you can move forward to the next stage of standardizing, protocols. And typically, if you look at elliptic curves, which were standardized through ECDSA and ECDH, in various industries, like in verticals, like the financial services industry, where you have the ANSI standards, you have a range of, IEEE standard that I worked on that I mentioned. So what we're expecting now, like with homomorphicencryption.org, we have our standard that our community has agreed on for underlying security levels. And now we're moving to the next stage. So we have an ISO working group that's being launched, and we're going to expect various verticals to have their own specific standards developed on top of the basic standard. So that's the pattern that I see like in every new crypto technology that we introduce, is that there's these stages and you move through the stages. There's pretty much no way to really speed it up that much. But in the end, hopefully what you have is government agencies, for example, hopefully NIST and others, ZKProof is already working with NIST, who are creating additional standards that companies around the world will trust and say, oh, this is standardized by NIST, NIST, 800-56 or 800-90 or whatever. That's why we know we can use this random number generator. So that's the process. I'm not sure if that answered the question, but
yeah, that's great.
That's kind of my mindset, how we standardization.
So I wanted to actually ask the same question from Kobe. So Kobe's an expert in differential privacy, which is sort of a miraculous adventure, I think, going from sort of very theoretical papers to companies, all these companies in the Silicon Valley at least, announcing that they're using differential privacy, which I never know exactly what that means because they use different parameters, or whether there's a lot of privacy, a lot of differential. And my question is to Kobe, is there any effort to standardize it, even if we don't mean standardize in the same way that it has been done in the zero knowledge and the FHE era, to talk about parameters, to talk about what is accuracy, how do you compare what different industry claim to use?
Yeah, so thanks, Shafi. First, I do think it's amazing to see how differential privacy came to be used by, or claimed to be used by many companies and agencies, and that's quite amazing. But It also points to the need to go through a more organized, more standardized process in using differential privacy. And I think I'm not aware of current attempts to standardize formally parts of differential privacy, but I think some of the efforts will generate de facto standards. For instance, the generation of standard libraries and so on. I think what is important to learn from the current experience is that a part of what needs to be understood and standardized is the process of developing and using differentially private products. For instance, how do you discuss the privacy parameter? How do you register it? How do you maintain the overall privacy budget? This is a big question that needs to be answered. Specific implementations, for instance, the implementations by Google, and this is Rapport, and by Apple, have used a model that is called the local model of differential privacy. I think there is certainly room for looking at this and other distribution models that the industry is interested in. For instance, currently there is the shuffle model of differential privacy that gets a lot of attention, and start to think of how to standardize them. I completely agree with Kristen that this standardization is essential for getting the public to trust these products in the end. I think differential privacy has been very fortunate that the technology emerged with also a strong need and a strong awareness about privacy in the public. So this is probably a strong force that pushed this, and that is still pushing this technology forward. But definitely to continue with this progress, I think we'll have to think about public trust, about interoperability between different systems and so on. And for that, we'll need at least some level of standardization.
Okay, thank you. So the next thing I wanted to ask, so zero knowledge is used in the context of MPC. In fact, I think it's one of its first usages after identity protection. Essentially to show how you can take a multi-party protocol technology and that works, let's say, for participants who follow the protocol, and say that it's going to work even if participants deviate from the protocol. So you're working your way from what we call a semi-honest adversary, where everybody follows the protocol, but they might be curious, to a malicious adversary. So they actually are trying actively to not follow the protocol, and you're adding zero knowledge mechanism to make sure they don't do that, or at least they will be detected. So I guess still, most of the research that has been done today, I think both on MPC and on FHE, assumes all the progress or the interesting results assume that the adversary is not malicious. So we are getting efficiency improvements, we are getting developing all kinds of data packing methods and so forth. They don't take into account the fact that an adversary may be malicious. So I wanted to ask two questions at the same time. One is that reasonable assumption? And second one is, are there any other usages for zero knowledge within MPC or other FHE cryptographic technologies which deviate from this, going from semi-honest to malicious application? And I wanted to present this question, I guess first to Yuval.
Hey, hi. So yeah, so I think that there are actually several interesting points related to the connection between MPC and zero knowledge. So as Shafi said, one of the beautiful and the first applications of zero knowledge was just to allow parties to prove sticking to the protocol without revealing their secrets. And this gave rise to the influential GMW compiler that takes any protocol with security against so-called semi-honest parties that follow the protocol into security against fully malicious parties. And I think that some kind of a slogan that has been repeatedly used in papers on practical MPC, including by myself, this approach is only theoretical, and therefore we need to design, very specialized techniques for each application to protect against malicious parties. And I think that today we're seeing different kinds of counterexamples to this common wisdom. First, we're seeing practical uses of this GMW paradigm. One recent example is a joint work with Mutu and Kermitu are here, and possibly others, that basically distributes an RSA key generation on a very large scale. And it turns out that for this type of protocol, we can apply a practical instance of the GMW compiler that uses the so-called MPC in the head approach to minimize the prover computation. So this is something that Mutu wrote in the Q&A part about having fast prover computation as an advantage of zero knowledge techniques that are so-called transparent, that do not require trusted setup and rely on a different kind of techniques than the typical ZK snarks that people talk about in this forum. So this is a practical application of the GMW paradigm. It actually applies zero knowledge proofs in the original context of compiling semi-honest to malicious. Another interesting direction is in the honest majority setting. So when Shafi, I guess that what Shafi said mainly referred to things like fully homomorphic encryption or advances in secure computation with no honest majority, but a different setting that was actually, it started from the Benor Goldwasser Wigderson paper and the Chaun-Kripot-Damgar paper from the late 80s, considered the case where you have 3 or more parties, a majority of which are honest, and it turns out that in this setting, we can get information theoretic security with higher communication complexity asymptotically than what we can get from fully homomorphic encryption, but with very lightweight computational security. So this connects to Josh's point about some settings where communication is fast and computation can become a bottleneck. And it turns out that the same type of proof systems that were motivated by zero knowledge snarks or by succinct computational soundproof systems can be used to generically compile these practical protocols like the BGW protocol to give full security with sublinear additive cost. And this can be made practical, and we've seen some recent works on that. So that's a second point of connection that takes these zero knowledge techniques that actually originate from ideas like Samcheck protocol from the 90s, from complexity theory, take these techniques and apply them in a totally different information theoretic honest majority MPC domain. And again, follow the original GMW paradigm, this vision of using zero knowledge as a general compiler, but applying it in a very different setting, in a distributed, honest majority setting. That's a second point of connection. And finally, I would like to mention a third point of connection, which actually relates to the post-quantum angle. So now there is this NIST competition for standardizing different post-quantum primitives, including post-quantum signatures. And some of the candidates, some of the promising candidates for post-quantum signatures use zero knowledge proofs. And these zero knowledge proofs are in a regime, they apply not to huge circuits, but to fairly small circuits. And it turns out that the type of zero knowledge proofs that are most suitable for these practical signature schemes happen to rely on MPC protocols via, again, a general compiler from honest majority MPC to zero knowledge proofs. So these zero knowledge proofs, they can be somewhat succinct. This is the Ligero system, but even if they're linear in the circuit size, it turns out to be the most practical for circuits that are not too big. So really when we talk about things being practical or efficient, there are so many application scenarios and parameter regimes. We need to be really careful. Experience shows us that whenever there is an interesting new idea, it finds the right type of application domain in which it will win over other cool ideas.
Thank you. So I want to turn to Vinod and ask you about maybe first of all, to comment also on the part that Yuval didn't get to, which is what you think about the reasonableness of assuming that the adversary is semi-honest. And maybe more interestingly, I know you've done work in the context of using AI and machine learning in the context of FHE, and whether you see any use for zero knowledge in that context.
Yeah, so the semi-honest setting is So when we talk about FHE and we define sort of the security of FHE, it's the semi-honest setting that we typically sort of define it in, and that might actually be reasonable when for example, in a setting where you have two parties, both with large collections of data, they want to collaborate. It's not that they are being malicious, but rather that regulations prevent them from sort of exchanging data in plain text. You could use sort of FHE and a semi-honest model is a reasonable thing to sort of shoot for in that world, but certainly sort of considering semi-honest adversaries is not the sort of the end all, as we very well know and what we sometimes what we've been saying in the FHE community is that the hard part is actually designing these FHE schemes, or rather equivalently secure two-party computation or multi-party computation protocols with low communication. In the semi-honest setting, that's actually the hard part. Let's kind of do it well and optimize it. And the rest of it, you can throw sort of zero knowledge at it, or you can throw sort of succinct zero knowledge or snarks at it. But I think there's a real opportunity to actually sort of, develop sort of an integrated solution, especially because the mathematical structures underlying FHE schemes, sort of rings and sort of packing and so forth, are very much the same as what zero knowledge, some of the zero knowledge proofs, so the succinct zero knowledge proofs use. So I think there's a real opportunity to actually go down that path and come up with a sort of an integrated system that that does sort of everything under sort of malicious with malicious security. That's an open problem for the community, for the 90 odd people out here. Okay, on zero knowledge in sort of ML and AI applications, I think even without the the sort of using zero knowledge to compile semi-honest to malicious is sort of an obvious sort of thing, and there are many situations in AI and ML where you would need sort of secure two-party computation protocols. So I'm not really even going to go there, but even zero knowledge sort of standalone is could actually be quite important in this world. Just sort of let me give you two examples. One is sort of this setting of try before you buy for sort of data and models. So there are people whose job, it turns out, is sort of to collect data, to curate it, and sort of sell it to other people. Or models, so the trained models, you want to sell it to other people. So let's say I'm actually at the other end of the spectrum, so I want to actually buy this data, but I don't sort of really sort of think that the data is what it is, or I don't know if it is, if it's useful to me. So what I would like to do is I would like to ask a few queries and collect the answers and say, what, this actually does satisfy. So this actually does classify cats, but not dogs. So how do you do this in a sort of a way that is sort of privacy preserving, in the sense that you don't want to tell me your whole data before I actually pay you, and on the other end, I might not want to sort of reveal the queries, but that's sort of a secondary concern. So one way to do this is you commit to your data and you prove that I'll ask you the queries and you prove that you give me the answers and that they're correct. So this is sort of an obvious application, and for models the same story. So that's one example. The other example is using sort of zero knowledge, digital signatures, MPCs, sort of this collection of sort of technologies to attest to provenance in data. So we all hear about sort of fake news, these news articles sort of getting going around the web. Each time a little bit of change is made, or a little bit of stuff is cut off, and things start looking very different from what they originally were. On the other hand, if you could sort of sign, or sort of if you could digitally sign the news article, for example, just a sort of toy sort of straw man example, and as it goes through sort of various sort of channels, they might get modified, and you actually might want the stories to get modified, summarized, and so forth, but they should all actually also come with a sort of a signature or a proof that these are the things that were done, and that could sort of play a role in sort of authenticating images from cameras, news articles, and so on and so forth. So that's another sort of place where crypto and zero knowledge type techniques interact with AI.
So I assume you're thinking about something like an homomorphic signature, where you can prove in zero knowledge that you've applied the right transformations. Yeah.
So really sort of the idea of homomorphic signature, probably not the schemes themselves, but sort of, some sort of variant of this. In fact, I think there is already some work on it. Iran, Tromer and others, they had this work on photo proofs. So that's sort of, saying, you can authenticate digitally signed images. And as they go through a small set of transformations, you can actually authenticate these transformations as well. So there, I guess, zero knowledge wasn't probably that important, but succinctness was important. So somehow if you have a sequence of 1,000 transformations, the proof should grow with 1,000.
So
can
actually,
I refer to another angle with respect to this?
I was
So
going
I think,
to turn to you.
I'm sorry?
I was going actually to turn to you.
Oh, sorry, I took your role. So another angle that is related to this question of semi-honest versus malicious versus other trust models that we have in cryptography is how these trust models match with what happens in reality, where we have restrictions which are either ethical or business or legal restrictions on how data can be used. For instance, we could think about government agencies that maybe are not allowed to share information across their boundaries, but still would be interested in computing over the data and link it or join it with other data sets and so on. And we have very little understanding how the mathematical models that we use in cryptography to represent trust match these models from real life, and whether these are good matches or bad matches.
So I have limited experience with that, kind of facing in the government and trying to kind of sell these applications. I think honest but curious honestly gets you pretty far, especially when it's privacy preserving. So like even if you mess with the query, you still kind of can't obtain the underlying sensitive data. Also, one of my personal favorites is the covert model, where I can catch you with probability 1/2. So like in other words, like if this, and we know you could do that with like essentially like twice the overhead or very, very low overhead. And like if the kind of consequences of catching you are, I know you're violating the law, that's something you're very disincentivized from doing. So yeah, full maliciousness is certainly required in some settings. I think in many agency settings, unless there's a truly adversarial relationship between the agencies, honest but curious can get you pretty far. And if there's like a regulatory part, covert can get you even further, where it's like, there's an incentiveness or even kind of a K, you can kind of start taking that further.
Yeah, just a comment that even fully malicious solutions still give the adversary in many applications a big freedom in choosing the inputs, which is
absolutely
of big areas like game theory, differential privacy, algorithmic fairness. These are all very popular and established areas that talk about what happens if malicious entities choose inputs in a bad way.
100%.
I guess another place which I was going to have Kobe elaborate on is in differential privacy. There's a question always about how much data you have, and you'd like not to overuse data. You have a notion of issue of whether your conclusions are independent or not, and perhaps this is using zero knowledge would be a way to reveal conclusions without revealing data. You want to say something about that?
Well, I think it's an interesting possibility that has not yet been researched. I think at least not in full. One direction where I think zero knowledge could play a role related to this, and the fact that we don't want to expose data or to overcompute over data, is when research findings are published with differential privacy. How do you then reproduce that research? And while I don't have a full answer to that, I think partial answer could be using zero knowledge. Maybe you could demonstrate that you computed correctly over the data without having to expose the data or your randomness. It will be interesting to see if we find other uses of differential of zero knowledge in differential privacy. By the way, another direction I think it would be useful is the fact that differential privacy is going distributed very strongly. We've seen, again, the applications by Google and Apple these are very distributed applications of differential privacy, and these are places where also, because of the distribution and the fact that it's actually a semi-honest model, there's room for manipulation, and maybe using zero knowledge, one could eliminate some of these vulnerabilities.
Okay, so this has been extremely interesting. I have actually a lot more questions that I was going to ask, but I have been instructed to let the audience speak as well. So I'm going to turn to the questions that I have from the audience. Okay, and I'm just going to throw a question out there and let you, you seem to be not shy. That's why you were chosen to be on the panel. So you could just chime in. So first question, can we use quantum no clone theorem plus quantum key distribution is a trusted setup protocol, for example, for zero knowledge snark? There are no quantum experts here, but I guess Vinod and Chris probably are as close as it gets. So Vinod, you look like you're opening your mouth. Go for it.
You know, in India, there's a saying which roughly translates to, you know, in a land of people with no nose, you know, the guy with half nose is the king. You know, there must be something similar in America as well.
Yeah.
You know, okay, so as a guy with a half
Every
nose,
language has its analog.
yeah. So, you know, one thing you could possibly do is use these sort of randomness generation protocols. You know, the quantum randomness generation protocols, they come with sort of, you know, you can press a button on a sort of a device, you get randomness together with the proof that it is random, whatever that means. And that could sort of be a mechanism to set up a common random string. Potentially also a reference string if you can actually prove statements, you know, in addition to, you know, to just sort of sampling random bits, and that possibly can be done too.
Yeah, just to note that the basic impossibilities of information theoretics, say secure two-party computations, apply also in the quantum setting. So it's not that you can get a secure computation unconditionally based on quantum.
Yeah, I wanted to add to what Vinod said. Definitely these trustworthy quantum randomness devices are a way to set up, potentially set up a common random string for the world to use. Many snarks require a trusted setup protocol where the common string is structured in some way. It has a trapdoor, and the secret trapdoor, if learned by somebody, would devastate the security properties of the system. I don't really see a way to do that with a quantum device. At least it's definitely not obvious how to do that. So yeah, the trusted setup is a significant downside for many of these systems that has to be mitigated.
Okay, another question by Mariana here is, differential privacy is often used on its own, independently of other crypto techniques. Can you comment on ways in which you think DP can interact with the rest of the techniques discussed here? So
I think it's important to point out fundamentally that cryptography doesn't secure the output of the computation, right? So if you're doing a computation where the underlying output is sensitive, yeah, we're going to secure the inputs, but the outputs are still going to be sensitive and could still like direct to somebody. So if anything, differential privacy and MPC are analogs, or are duals of each other. Differential privacy protects the input, it essentially protects the, well, I'm saying this in front of Kobe and others, but like protects the kind of privacy of the individual inputs, but doesn't necessarily, you know, secure the inputs themselves. Cryptography, you know, MPC secures the inputs. So they're very, very nice kind of when combined, and it would not be surprising in the nearest term to see them used in combination.
Yeah, I wanted to add that, so my team's worked on actually combining both DP with homomorphic encryption and combining DP with MPC. So we did have one paper specifically for neural net predictions, but other work in progress on other machine learning models, where if you add, you know, MPC and differential privacy together, it's like Josh said, you know, you're helping to secure the output. So the model that you was jointly trained, for example, could be released, but only in differentially private form to everyone. And not only that can help protect, you know, the inputs that were used to train the model, you know, using MPC, but also, interestingly, because machine learning is an approximate process, it did not degrade the quality of the models that were trained. So in other words, you think you're learning some pattern from some data set. Well, at least experimentally, we've observed, and it's probably known by other experts in the community more broadly, that fuzzing the data and training on approximately the same data set, can give you just as good of an outcome. So combining differential privacy with MPC, and machine learning can be very fruitful. And the same can be true of homomorphic encryption. So if you're, out using, let's say, multi-key, and you want multi-key homomorphic encryption, and you want to train across different data sets, we expect the same underlying thing to be true, that it's not going to degrade the quality of your model if you added noise to the input. And then in the end, the model that you share, you may be able to avoid leaking information about the data sets that were input. So that's our observation experimentally. And DP combines well with homomorphic encryption because both of them are just adding noise. So it's a very nice symbiosis between DP and HE there.
Let me mention one more place where there's currently a lot of symbiosis between crypto and differential privacies. And this is a model that Yuval and others have produced in 2006, I believe. It's the Cryptography from Anonymity paper. And this idea now has a revival in the differential privacy literature. It turns out that marrying this shuffle that they suggested, the anonymizers with differential privacy, is an interesting and hopefully also useful distribution model for differential privacy that produces error levels that are much better than those that we are getting in the local model of differential privacy.
I want to ask, there's one more question on the chat, then I want to ask a question. So the chat question is, will this standardization effort, I think this refers to the zero knowledge standardization effort, eventually cover ZK proofs that faithfully capture physical properties, or will that remain out of scope for the near future? I'm not sure who in the panel wants to weigh in on this. It seems more relevant to people who were part of the zero knowledge standardization effort. Anybody? No, then I'll ask my question. See, that's my prerogative as a panel moderator. So in our discussions prior to the panel itself, I think Yuval, you brought up this question of models in a multi-party computation setting where we talk about collusions. So when we do secret sharing or we do MPC and we have some idea in our mind of how many people are colluding and what way they're colluding, and is there some way that we can verify that or test that? So I was wondering if you could elaborate on those thoughts.
Right, so first of all, I think it's kind of related to your previous question about semi-honest model, and also the legal issues that Kobe talked about are relevant. But I think that orthogonal to the legal issues, there is the very practical question of what are real, who are we concerned, who is the adversary, what is the adversary capable of, to what extent are we better off if we can split our trust, say, between Microsoft and Amazon versus Microsoft and a company in China. So that is because even primitives like very basic ones like secret sharing, we want to keep our coins safe. We want, even before we talk about more advanced crypto technologies, there is a question of how to do it and what is the actual combined level of trust or combined resilience we get by splitting trust between different entities. And it would be great, actually that's something to pitch to the applied people here, but it would be great, or maybe to Josh to run a program to try and have some kind of empirical evaluation of what real world attackers are capable of. To what extent is the probability of breaking into two systems at the same time the product of the two probabilities, right? This is something that's quite intriguing.
So I think, we did something like that. Actually, we ran a workshop called Applications and Barriers to Consensus Protocols. We were particularly looking at permissionless consensus protocols. And one of the kind of 3 research prompts that we asked and we solicited talks for was, what are the underlying centralities of decentralized systems, right? Because, there's this assumption, frankly, especially in the cryptocurrency world, where if you decentralize things enough, like suddenly it's more secure. And it's really, the challenge with that is you're really dealing on very different levels of abstraction, right? So the fact that a blockchain is happening in many places, they're running the same software, like they're all vulnerable to the same vulnerability. So, there's great papers on Bitcoin and how centralized it was on particular networks. There was some great work presented from CAST on how they were doing, there's this like trilemma of things associated with centralization, and they're using a somewhat, I think, academic definition of decentrality. But the long and short of it is like, this is a massively open research problem because I think we do not at all fully appreciate from a truly practical standpoint how centralized some of these systems are. So in terms of whether we're going to do a future research program on it, that remains to be seen. But I definitely think there's there's really a lot of interesting questions in that space.
Great. In fact, so one thing that emerges to me from all of these discussions is that we have a lot of, regardless of the technology, whether it's FHE or MPC or DP or zero knowledge, we have a lot of similar concerns coming up, the adversarial model being one of them. The fact that there's a lot of settings where we don't want to expose the data, and it's not just a question of the model of the adversary. It might be legal issues, there might be regulations, there might be independence of data. So really being able to prove that our conclusions and use probability laws in a way that's sound by not revealing it and yet being able to use the conclusions. Another thing that has come up, we won't have time to discuss it, but it's come up through these 5 weeks, is the question of interoperability between different proposals, different blockchains, and the fact that this is something that the lack of interoperability is something that that stops the scaling effort. So in other words, in order to be able to scale, we have to be able to move from one blockchain technology to another, one system to another easily. And I think that's true also within cryptographic primitives, to make sure that it's consistent between DP to MPC to FHE, even within different FHE proposals. If all of us are if we are fragmented, everybody's using a different system, it's going to be much less possible to scale. I see this very much actually today with the contact tracing efforts, even if we bring it to this moment in time, that I think now, like the Google, Apple, they want to have one app just so that the whole country uses the same app, because otherwise they're saying it's not going to be sufficient use. So I think that's true also for us, that we have to work together also just to get the thing out there. I think our time is up. And I want to really thank you. This has been extremely interesting. I'm glad it's being recorded. I myself will listen to it again. A lot of research opportunities, a lot of interesting questions. Thank you.
Thank you, Shafi.
Thanks.
Thank you. Thanks, everyone.
Thank
Bye.
you very much.
Thank you, everybody. Hope to see you all in person soon.
Thank you all for the panel. Thank you, Shafi, for the great moderation. This was extremely, extremely interesting. We'll definitely be publishing this in the coming days, so you can also have it available.
Thank you so much. Bye-bye.
Bye. Okay. So that was very, very nice. I mean, I very much enjoyed it. I hope you all did as well. We would like to continue to our last session of the workshop of this session and the day. It's mixed feelings. Things are going to be done soon, but actually we're very excited about this coming session because we are going to essentially appreciate the community. We have a strong belief that the community is the most fundamental part of ZKProof, of the effort, of the workshops. I mean, we've had, consistently at least 70 or 80 of you coming to every single session. That's definitely not trivial, and we're very happy about that. I'm going to hit record just so that we actually have this recording as well. So we actually have a few surprises for you during this session. But before that, I would like to sort of do a very short recap so that we kind of go home with a good feeling and sort of try to close the loop here on what experiences we had. And of course, we want to hear from you at any point. Feel free to email us, and you'll be getting a survey at some point. So first of all, right, we saw this slide. Aviv presented this slide in the opening remarks of the first day, and now I'm showing it again because it really is a reminder of how much of a challenge this was for everybody around the coronavirus, and specifically for ZKProof because we had to sort of change everything. And we're very happy that the way it turned out. Because of many reasons, but we believe that one of the reasons was that it was more accessible for people, and we're happy that was the case. So again, thank you to all, and this is what it turned out to be, right? Past years we saw some other pictures in person, and here this is our new group picture, right? Let's say. So I guess now we will be showing this around when we talk about ZKProof. We hope that next year we will go back to physical, but we never know, right? So we're excited to keep working with you all and to sort of have ongoing events, even if they have to be online. So definitely expect more of those. Once more, we would like to thank all of our sponsors. Definitely without them, this would have not taken place, and their support, their ongoing support. I will say that none of the sponsors sort of put any roadblock on us once we decided to change to an online event. So we really thank everybody, specifically IOHK, KEDIT, and the Zcash Foundation, who've been supporting us greatly, and all of the rest. I would like to thank again the steering committee, because they are really a fundamental part of this effort. They're the guiding team of the effort, making sure that the standardization proceeds, that the interests of the whole community are present and whatnot. As you can see from the faces here, many of the steering committee members have actually given talks, moderated. You've seen many of them, most of them throughout this workshop, and that is an attestation of how their involvement and how much they see this effort meaningful. So just to sort of do this sort of recap now, I want to share with you a few numbers. I mean, they can mean more to some, less to some, but basically, what have we achieved in this workshop? Right after 5 weeks of ongoing discussions and so on, it seemed very packed at the beginning. We actually had around exactly 302 registered participants as of this morning. So that's a pretty important challenge, I guess. Last year we had around 140, and it was double the previous year. We didn't expect to have double of the previous year this year, but now that it was online, I guess we actually saw that happen. Out of those 300, I guess not no session was 300 at once, but we had an average of around 100, 110 participants every session, which is quite amazing if you think that 100 people sort of followed through on average on every session, and we really appreciate that. It shows and attests to the support of the community. As you probably know by now, we have 12 working groups that were created. So this is also an attestation of how important this effort is to sort of bring the standardization to a reality, right? So we don't have an expectation that all of the working groups will end up creating a standard, right? We encourage all the participation and things like this. I'll talk about this in a second a little bit more. And this number does include the primitives working group that we created and merged the merged working group of Commit, Improve, and Savor, right? So if you don't know exactly what it means, you can go to the website that I'll show you in a second, and that will show it. And of course, something that I think is sort of for eternity as well, at least as long as cloud exists on YouTube, we have more than 25 hours of content, right? We're going to be publishing all the content for anybody to see it. So far, it's been only reserved for the participants of the workshop, but now it's actually going to be for everybody. So if you have an issue with that, please do email us. We wouldn't want to overstep. And you know, this is of course these are not only the achievements, right? We've seen, you know, a lot of support around the standardization. The discussions have been incredible. You know, I think it shows about how many opinions there are, how fast this field is advancing, and the fact that we need to start seeing somehow where things are starting to settle in order to be adopted even more at scale. So we're very much excited to see where the working groups are going. And of course, we've been building a lot of the community. This workshop, compared to a 3-day workshop, I think allowed people to sort of engage with each other a little bit more throughout time, right? So connections may be a little bit stronger, although of course not physical. So there is a little bit of a trade-off there, but we think that the networking sessions, at least from the feedback that we got, really encouraged the community building, and Yao will talk a bit about that in a few minutes. And so we're very excited about how this workshop turned out, and we really consider it a success. And you know, so the question now is really, what is next, right? How do we want this to proceed? Of course, the workshop is not the end of the effort. The effort has been going on for now 2.5 years, and we're very excited to see what's coming up, right? We started all kinds of collaborations with NIST and with other standardization efforts. Actually, we have more sort of discussions ongoing right now. And we want the community to be stronger. We want the content to continue being developed. So we spoke a little bit about the standards working groups. We encourage everybody to join those standard working groups. And you know, you will find in the community forum of the ZKProof effort all of the working groups that are available, and we encourage you to join those that are interesting to you. And you know, we'll be sending out some guidelines in the coming week or two around, you know, what should be sort of maybe a default behavior for these working groups. Whereas, you know, each working group sort of has the flexibility to decide what's better for them in terms of meetings, in terms of deadlines and meetings and so on. So we encourage proactivity in these working groups. Don't expect or wait for someone to just you know, take the lead. There are some leaders of the working group, but please be proactive. That's the best way that the working groups will advance. And you know, we would like the first steps at least to be sort of to define the scope, the goals, and the milestones of the working group, right? At least initially. And sort of we would like this to be part of a charter, an initial charter. And so far, we think that the best thing to have is sort of a charter by the end of August. This would be sort of a flexible or medium-term due date, but it does put sort of a bit of a hard deadline on moving forward with the working group, right? And this is one of the ways that our content at ZKProof is evolving. And the other one, as you saw maybe on Monday, is the community reference, right? And this is probably the most important part so far, given that we don't actually have a standard, but we have a reference document. And that this is an incredible collaborative effort, as you saw. You can find all of the details here in the documentation page /reference. And as we discussed, our first phase is sort of to get some reviews. So if you're going to go ahead and read the reference document, please do try to make it as more of a formal review. Take notes, you know, even annotate a PDF or even go on the GitHub and take do a PR on a branch, something that will enable us to get feedback from you. And if you want to email us, you just go to editors@zkproof.org. And you have a chance to join over 70 contributors, right? This is a document that started in the first workshop, and so far we've had around 70 people contribute. So you know, it's pretty important, and we know, as a matter of fact, that it has a huge potential to impact the community at large, right? In that sense, don't forget about the story of Alice in ZK Wonderland, right? It's very important that she will get her tutorial and be able to master zero knowledge at the end of her career. So with that being said, I very much appreciate your time and you listening to us and to me specifically, Mumble Wumble. And so I'm going to let Yao take over. He's going to continue with some very interesting stuff and for the community. So Yao, would you like to take it on?
Yes. Thank you, Daniel. It's been an amazing journey. And thank you all of you who are with us. So we have people here on Zoom. We have people watching us on YouTube. And we have many more people that will be watching this recording. And for those of you who are here, we are in the dessert. So if until now we had the main course, now it's time for some nice dessert and some sweet stuff to really enjoy. And I want to reiterate what Daniel said about ZKProof being a community. And ZKProof is definitely a community. We've been meeting every day, twice a week in the past 5 weeks. And this is the third workshop. But it's not a regular community because we are a community that generates value. And we really see tangible value coming out of these sessions, and like really a technology standard is evolving in front of our eyes, and we can't take it for granted. And we want to keep the ball rolling and keep generating value. And the ZKProof community badges is part of our way to encourage the people who generate value and incentivize more people to participate in this value creation. So let's see what we've got for you today. The first type of badges is called the growth badges. And these are badges that you receive simply by participating in the ZKProof workshops. So the numbers of stars represent how many workshops you've participated so far. So after this workshop concludes, some of you will receive this 2 stars badge that symbolizes that you've been to 2 workshops. Those of you who've been to a workshop before, others will get the 3 stars badge. And we have also 2 badges reserved for the next workshops. For those of you who continue to join the workshops, 4 stars, and also the 5 stars one for 2022. And these badges are digital, so they will be sent over email, and they are also verifiable. So we are able to verify the authenticity of them. And yeah, so it's quite a cool thing. And in the future, we aim to make them physical. So we actually aim to make physical badges that we can all wear on our clothes, or stickers to put on our laptops and doors and fridges. So this is the first type of badge that many of you will receive. But there's also another type of badges that we want to introduce today, and these are the accomplishment badges. So for these badges, it's not enough just to show up to the workshop. It's also about contributing and generating value. And I want to introduce you the new ZKProof accomplishment badges. They are all taken from the mythological creature world. And part of what we're trying to do here is to create a new cultural reference to our community. So from now on, if you are a ZKProof trailblazer, it means you're a community leader. That means that you are very active in our community forum and you contribute to working groups, into the discussions. If you're a ZKProof storyteller, it means you wrote a proposal that were accepted, and so on. Each of these has a definition. A chronicler is the people who took notes during the sessions. A wizard is the designers and creatives that support the ZKProof community in generating visuals such as these badges. And the oracle are the reference contributors. So this is really our way to reward the people who contribute and make the community flourish. So these also you will receive in your you will receive a digital verifiable format if you're one of these categories. We want to continue, and now that we gave the badges, we also want to give some awards. And these awards are you can think about it like the ZKProof Oscar. So that for the people who were contributors who were selected as meaningful and impactful in this workshop. Daniel, are we ready to start the ceremony?
Let's do it, Yao. I think this is an exciting time for ZKProof. It's the first awards we give, right?
Okay, I will give the first award as a warm-up, and then I will pass it away to other esteemed guests that we have here. So the first award is given for the note takers. So the note takers receive a badge, but we also give them an award because that's really a significant and part of the community and keeping the standardization effort move forward. So they will receive a special prize. And the prize that they will receive is first a free ticket to ZKProof 2021. We hope it will be a physical event, but if not, in 2021, they will receive a free ticket to the next physical ZKProof workshop. And they also receive a special version of Cards Against Cryptography, which is a really cool board game you can play with your friends at home that will be sent to their homes. And the winners are, so this is less exciting because we know who took the notes, but I still want to acknowledge everyone. So we have Anais Carroll, Dara Hopwood, Mary Muller, Abida Hake, Markov Kolweiss, and Michele Oru. Thank you for the 6 of you who really took the effort to take notes and do an amazing job in that. So kudos to you. And now to the next award, Best Lightning Talk. I want to give the floor to Daniel to introduce the next.
Mutu is going to introduce this.
Yes, Mutu.
That's okay if Daniel wants to do it too. Thanks, Yao. You said it very well. These talks actually are an important part of our community building and also knowing what are the latest accomplishments, both in the industry as well as in academia coming out in zero knowledge proofs. This year, this was held in session 4, April 30th. There were like 12 talks. And we've decided to give the award for the best lightning talk.
Next
this
slide,
award, this award, as before, it comes with a free ticket to ZKProof 2021 and Cards Against Cryptography. And this year, the award goes to, next slide, Karim Bagheri for Tiramisu, black box simulation extractable NIZKs in the updatable CRS model. I just want to say one thing from the talk. I didn't get to attend it, but I'm going to say that Tiramisu literally means pull me up, lift me up.
Beautiful.
Congratulations, Karim.
Well done, Karim. I also say that it was chosen by a vote done by the community members.
The next award is for the most impactful discussion. Again, this, I think, having moved to, this was one of the advantages of having moved to an online-only conference. We were able to have really meaningful discussions after every sessions. There were questions which the speakers really got the opportunity to address during the talk, and we are giving the award for the most impactful discussion among all the sessions. And the award for this goes for a special recognition on the ZKProof website for this discussion and a specially designed certificate from ZKProof for this. And the award this year goes to the Commit and Prove Zero Knowledge Proof Systems, and the authors of which were Daniel Benaroch, Matteo Campanelli, and Dario Fiore. Congratulations all.
Congratulations. This is again was chosen by the community in an open vote.
Thank you very much, Mutu, and congrats to Karim and to Dario and Matteo. This next award is very important. It really sort of aims to highlight the importance of participation during this workshop and sort of the real impact that it can have. Next slide, please. In terms of prize, I mean, we don't want to say that there is a huge prize behind this, but it's really about the recognition that it will incentivize others to really participate as well, and have a dedication for the effort in order to make this standardization happen. And the prize will be, a recognition on the website and a certificate that we hope to maybe send physically to the winner. And the award, next slide, please. So the award to the most valuable participant is sort of as actually, I think it was Eran Tromer who put it this way. It shows the individual's effort that have substantially contributed to the lasting impact of this workshop in the field of zero knowledge proofs and the ZKProof standardization effort. And the award this year for the most valuable participant goes to Dara Hopwood from the Electric Coin Company. But we really want to congratulate Dara. This it shows how much Dara has been helping to push this effort. I would actually like to invite Dara to say a few words. So let me bring her in. Hi, Dara.
Hi, can you see and hear me?
Yes, we can.
Okay, so thank you for the award, and thank you for to all the organizers and the participants. I just wanted to get on my soapbox a little bit. We're all here because we believe in privacy. We believe that people deserve a right to privacy, and privacy can make the world better. It's necessary for a fulfilled intellectual life, public life, private life. But that we do need to consider whether the systems that we build are always making things better. I don't want to, the point of this is not to dunk on any participant or example, but I heard a few things that had me a little bit concerned. For example, the idea of matching people against a database of bad tenants. That kind of, I mean, my family has been evicted twice. It's not the protocol that's going to determine who's on that list. It's existing power structures. And we have to be very careful that the systems we build are not reinforcing power structures that are detrimental to people, that discriminate against people. So that's the main thing that I wanted to say. Thank you very much.
Thank you very much, Dara. Again, applaud for all your contributions. It really has been very, very significant. So I'm gonna push you back to the attendees, but thank you very much for saying those words. Next, and actually last but not least of the awards will be presented by Abi Shalat, who's the co-chair of the reviewing committee. And this is an award that was chosen by all the reviewing committee. So please, Abi.
Yes, I think the entire PC voted, and as hard as we tried, I think there are 2 papers that we're going to give the best.
Abi, can you please speak a bit louder? You're quite low in volume.
Is this any better?
A little bit.
I'm sorry.
Yeah, we can hear you. We can hear you.
I'm trying my best. It's Bluetooth. So the best paper award. So there are 2 papers we're going to give an award to. We took a vote, and these were basically tied. Let's see which one the first slide is for. Yes, of course, the prize is going to be, again, special recognition on the website, as well as a specially designed certificate. But of course, it's mostly the laurel wreath that you wear and you put on your CV. So the first best paper, should we do the next slide? Okay, great. They're both on the same slide. So the first best paper is the benchmarking framework for zero knowledge proof systems by Daniel, Oral Nichols, Justin Thaler, and Eran Tromer. And this is a fantastic paper that basically it summarizes the challenges in building a fair evaluation framework for these systems. And I think it involves, takes a very holistic approach and encourages quality and consistency. And I think it's going to have a huge impact, especially if these ideas are taken to implementation. And I think it will help, as I've often said, the universe is vast and there are many different types of ZK-proof systems, each of which have their kind of special place. And I think this paper makes a very good argument supporting, basically describing this idea. The second paper is the TurboPlank program syntax for specifying SNARK programs by Ariel and Zachary Williamson. And this is a very interesting paper too, because it sort of presents a new representation for which verifier constraints are not checked in the exponent. And so they go through this idea, and then they basically benchmark several examples that show you can get a constant factor, a reasonable constant factor improvement. Congratulations to both of these papers, and I guess congratulations, and thank you for submitting such good work to this workshop.
Thank you so much, Abhi. Thank you for taking the time to chair the reviewing committee and putting the effort to make this happen. These 12 papers were absolutely amazing. And congrats again to all the winners. So now we just sort of, in order to close and hopefully not to leave you all with too much of a taste in your mouth, we would like to have two members of our esteemed steering committee give a few closing remarks. So Jens and Aviv, please Jens start, and then Aviv, suppose. Thank you.
Yeah, well, first of all, thank you to all of you who have been participating. It's been absolutely fantastic and great that we could double the numbers this year, despite the unfortunate circumstances that caused it. I live in London, so I had really hoped that it would be held in London and I could attend in person, but maybe next year. I think it's been very interesting. I was looking through the community reference, which really covers a lot of diverse topics in zero knowledge proofs. It's grown to almost 100 pages now. And it covers representations of statements, intermediate statements, definitions, and assumptions, efficiency, benchmarks we could use, and interoperability between zero knowledge proofs, zero knowledge proofs with different other components, commitments, for instance, and applications of zero knowledge proofs, which of course also needs standards to really convince everybody that this is the right kind of zero knowledge proofs to use. And then I was looking at the program, and it really covered almost all of these topics. So we had quite a variety of contribution. I think that's great. I guess the only thing missing out was the assumptions part, but maybe next year. So let that be an encouragement to all of you. So the other thing I was thinking about is, and of course it was a different format this year, but I think it was great that we could get so many people together and we really have some good discussions. I think the discussions were very active, and I think this is also something that differentiates zero knowledge proofs from other academic workshops, where typically you get a presentation, you have a few questions along the way, and then you have to take everything else offline. But here we really managed to have discussions that involved a lot of participants and a lot of good questions and modifications that came to the proposals. And of course, that's also the part of the ZK-proof, right? That it really is about bringing the community together, and we want to promote not so much novelty, right, but usage and general value. And I think the way we are building up the community reference, the way we are discussing and refining the proposals that people make really help in that process. And it is a very different experience from a typical academic conference, but something I really do enjoy. I always look forward to ZK-proof. So let me finish by saying thank you to everybody, speakers, organizers, and the audience, and encourage and hope that we'll all see each other again next year. And if the doubling continues, I guess it'll be 600 participants next year and even greater impact. So thank you.
Thank you, Jens.
Yeah, I think I'll join Jens with all these thanks. But I really want to say I'm glad to see so many people who made it to this point of the conference. It's not easy to follow us for 5 weeks, for 2 sessions a week, especially with the COVID-19 pandemic. It's been hard, I guess, for all the speakers and participants who were sheltered in place with their lives disrupted. And I hope wherever you are in the world, things are improving, and that we're moving towards the ability to meet in person as soon as everybody really wants. I think as we close this this conference, the underlying motivation of ZKProof, I said it at the beginning, is as relevant as ever. You may have heard in Israel that the threat of the pandemic drove our government to employ surveillance tools that are used by the security services for contact tracing. So, you know, the level to which our privacy is respected is always being challenged, especially when there are adverse conditions to our health and our well-being. So again, I really want to join everybody in thanking the participants, the review committee, the session chairs, the keynote speakers, panelists, the proposal presenters, everybody who was organized. But I think we have to really recognize Daniel and Yao for running this event so seamlessly. I think you also their attempted or sometimes successful, sometimes less successful at originality in how to run an online event that will still be engaging, that will still allow you to mix and mingle with people, to motivate people to join, right? With the breakouts that we had, with badges that you've just seen, and with some swag that we mailed participants, right? So this is all them behind the scenes working very hard, and really they should be applauded twice, because they really organized 2 conferences, a physical one that was supposed to take place in London that they later had to cancel everything, and an online one which has never been done before in this format. So like many events that have gone online, I think we were among the first to make this switch because of the timing. And again, I want to finish by just urging you from a practical short-term perspective to continue your involvement with the effort. This is really our crunch time. We have some great proposals on the table that need to be pushed forward. I urge you all to participate in the working groups and to contribute, and to send us feedback and ideas about next events. What should we do? If you want to help us to host one, or you want to sponsor, we really want to hear from you all. And thank you all for attending.
Thank you very much, everyone. I'm going to now stop the recording, the last recording, until next time again, I guess. Thank you, Aviv and Jens again.
Thank you. Have a great evening.
Thanks, everybody.